Hello, everyone. I don't know what time zone you're in, so good morning, good afternoon. My name is Len Henry. I'm the team lead of the field CTO team inside of Google Cloud Startups. The team I'm a part of, we basically act as mentors for startups. We're all folks with fairly long years of experience. For example, I've worked in cloud now for 10 years, 5 years at Google, 5 years at Amazon. And we've also had background in working in startups, and also some of us like myself have had CTO roles. Most of my experience has been in DevOps, containerization, what we call here application ecosystem, which is how you modernize applications. So we have a lot of content to go through here. So you may find that me and my presenters are going through very quickly, but we will have chances for you to ask questions, and definitely use the chat for any questions that you may have for us. So let's jump right in and talk about some of these technologies. So, of course, we're going to be talking about AI. I mean, that's going to be a top of mind for a lot of different things you're going to talk to Google Cloud about. But what we've learned in our experience with AI is that AI demands a strong foundation. You basically have to make a choice between either the ultimate control or the fastest path to production. But the two paths are essentially infrastructure or platform. Either way you go, we believe that Google Cloud provides you a first-class experience. So the infrastructure path gives you the ultimate control and performance. You get granular control, high performance, customizable options, and it really fits when you have complex workloads. The platform path is about rapid development, reduced overhead for operational things, simplified deployment, and a comprehensive services and a long list of managed services that can do all the type of things that you would otherwise have to organize for yourself. So the AI hypercomputer slide, you're going to find that a lot in conversations with Google Cloud about infrastructure. And what it basically represents is all the different layers in which Google Cloud provides things to be able to help you solve your AI problems. Everything from purpose-built hardware, optimized software, and flexible consumption options for how you can actually make use of that hardware. So let's talk a little bit about infrastructure path. We're going to spend a little time about some of the instances, including some of the new things that came out of Next. So sometimes folks are surprised when they realize what a long history of developing hardware Google has had. In particular, because Google has been using AI for such a long time, we actually had to develop custom hardware because none was available from other vendors. So we have a lot of experience in developing AI-specific hardware and custom compute solutions to be able to meet the needs of our massive world-scale applications. So now Google Cloud has, because based off of all of that investment in development of hardware, there's all sorts of compute solutions available for our customers for all sorts of different types of workloads. And we believe that we offer a pretty competitive offering, from general purpose to specialized like high performance computing and machine learning. And we've had significant growth in including some market leading options available for our customers. So there's two different types of instances that we've had significant investment in, other than outside of GPUs and TPUs. So our N series is optimized for best price performance, and really it's about reducing TCO, and that gives you a lot of flexibility and a lot of options for how you can optimize and get the best value for your money. The C series is really about the highest performance, and it gives it easier maintenance and some of the largest footprint in terms of CPUs and memory. So for C4, we've actually had extended shapes for C4. This is the newest 6th generation Intel Granite Rapids processors, up to 4.2 gigahertz, larger caches, and increased memory bandwidth. So what's new about this is some of these new shapes, which includes up to 288 vCPU and up to 2.2 terabytes of RAM. And what you'll see from these new shapes is 65% better performance from the machine learning recommendation workloads, 35% better bare metal performance, and lower latency with titanium SSD, which I'll talk about a little later. So some of the other new stuff is the local SSD for C4s and C4 bare metal, and you can use this QR code to sign up for preview. Now, Axion is the latest version of our ARM-based custom processor, which gives you up to 10% better performance when compared to leading cloud providers, and 65% better price performance, and 60% better energy efficiency. And it's also standard space, so it has pretty broad ecosystem support, so lots of different libraries and development kits and also platforms can run on top of Axion. And in fact, we always recommend customers just try it with the ARM-based processors and then see if you have to do some code changes to support it. You can see the performance improvements you can get with the C4A types, and it's now in GA with the titanium local SSDs, which gives a really low latency and high throughput. Axion types are now also available with Cloud SQL instances in preview, and so that's something you can contact your account team to get access to the preview of using Axion with Cloud SQL. Axion also powers a lot of Google Cloud services as well in the background, so that's just something to be aware of. This is a very well-used technology for us. So we now have specialized instances for HPC workloads, and that's what we call this H4Ds. It's optimized for HPC. It also supports cloud or remote direct memory access, which is actually what we have. The titanium stuff is what supports our GPU, which we'll talk a little bit about later. It supports large and flexible HPC cluster, and it has support for cluster director and DWS, which is two of our ways of consuming compute resources. And there's a preview for that available. Z3 is our storage optimized types with up to 6 million IOPS, which is really incredible to say that we have that amount of support for storage. The titanium SSDs gives you up to 36 gigabytes of storage per second of storage and up to 35% lower latency. And it's designed for storage intensive workloads, things like databases, anything that you need higher performance disk access. M4s is the new general purpose type, 66% better price performance, has a broad set of memory sizes. M4 types is also SAP certified as well, so you can run SAP workloads. And some of the other benefits that you get is that you have up to 1.4 terabytes of memory and 56 or 112 vCPUs. And the M4 supports up to 6 terabytes of memory, actually. That's in preview. Now, in order to make use of AI workloads, it's really important to have hardware specifically designed for AI workloads. We have a bunch of purpose-built infrastructure for running AI workloads. We also have very advanced hardware from other vendors to be able to run AI workloads as well. So let's start by talking about some of the purpose-built hardware innovations that we've announced recently. Now, Trillium is our 6th-gen processor that's been out for some time now. And what you can expect with Trillium, which is our TPU, which is our alternative for GPUs for AI workloads like training and inference. The Trillium has 4 times the performance for training versus the prior generation. It has 3 times the inference performance. But now we've announced Ironwood, which is our 7th generation. It's really amazing to think that that's the 7th generation of TPU type. Some of the expectations you can expect for performance based on the numbers, 5 times the peak compute performance. I mean, if you think going across a generation 5 times, that's tremendous. Some of the things that you get with this generation of, they're actually already planning an expansion of the 7th generation. So TPU V7 Ironwood is going to have 256 chips per pod, but they've already planned out TPU 7X, which is going to have over 9,000 chips per pod. So if you think about what's possible with those new hardware and what you can expect with performance improvements for doing the training and inference. We also have a lot of Google Cloud GPUs that are available as well. We were the first to market with both the NVIDIA B200 and the NVIDIA GB200 with NVIDIA Link 72. So here's some of the existing instances and some of the ones that we've announced that are coming. And actually, the A4X is in preview as well. So the A3 Ultra and the A4 have been out for a certain time now. And then the A4X is in preview. And then the NVIDIA RTX Pro, that's something that's coming later on this year. All of those are built on the Titanium ML network adapter, and I'll talk a little bit about Titanium a little later. And then you can, of course, leverage Cluster Director, which is what we recommend in order to make use of some of these GPU instances. So A4 was the first B200 VM in the cloud. And like I mentioned before, we're also coming with the GB200. And then you can see the performance improvements for the A4X, which is the most powerful GPU VM that's available. So for training and inference, one of the challenges that you'll run into for these types of workload is that you need to be able to do quick setup. It's really essential that you don't have to spend a lot of time to be able to make use of resources. You want to be able to react and troubleshoot troubleshoot issues that are going on. And then it's really important to support checkpointing and workload continuity, because all sorts of things can happen, especially when you're doing large scale training jobs. So it's really important that you're able to actually stop and continue with your work. So Cluster Director, this is generally available. And really what this is for is to be able to easily deploy and manage large compute clusters. Some of the key features of Cluster Director is that management, it also supports observability and continuity. And these are really the key parts of why we came out with Cluster Director. So here's a really quick kind of demo of how Cluster Director works. You're able to spin up a cluster. You can make choices like your VPC, some of the network settings. You have choices of what storage you want to use, and then you have a choice of which orchestration, like you can use Slurm or Cluster Toolkit for managing. And then that's how quickly and easily you can establish a cluster, and then that's pretty much it, right? Once you set up a cluster, you now have the ability to observe what's going on in the cluster, and you can get insight into how your jobs are running in the cluster. And some of the things you can do is you can actually replace stragglers, meaning that something where work is not happening. You can also change some of the settings like add resources, change the type of resources that exist inside the cluster. You can also do things in a group. So you can replace an individual node, or you can actually replace all the nodes. So this is like a big deal when it comes to running like a really large job. So you don't have to manually manage individual things. And then once you have this observability, you can do things like maintenance by updates. There's all sorts of things that you can do very quickly inside of at this level, rather than have to do it at individual node level. So let's transition and talking about some of the other new tech that we have for your Gen AI workloads. Now we know Gen AI is everywhere, but when you have data sovereignty requirement, you have some AI infrastructure complexity. For example, you're using data from IoT devices on-prem. You have inconsistent hybrid environments, or you have, you're working with some things that are just not necessarily something that exists within the public cloud ecosystem. We have our Google Distributed Cloud product, and that gives you a lot of fully managed services on-prem, and it's built on Kubernetes, so it's really standard technology and allows you to start small and scale. But one of the things we've also announced is that we now allow you to use Gemini on-prem, which allows you to run Gemini either in a connected or air-gapped configuration. So some of the things it supports is, you get really powerful compute for doing things like model serving, and you can run it in an air-gapped way so that it can support whatever compliance requirements you have. Pathways is a new distributed runtime, which we have, which actually powers our training and inference infrastructure for Gemini. We're now making it available so you can make use of it yourself. And what Pathways does is it supports flexible orchestration, elastic training, and then it essentially gives you an interactive way to manage your supercomputing resources. So in traditional training, you pretty much forced to have the same computation on all hosts. You kind of have handwritten control, which is separate from training code, and then you don't have a lot of interactivity, and then debugging at scale is very hard. So with Pathways, you get really flexible computing. Training code is what controls how your infrastructure is used, and you get interactive activity at any scale. So out of the box with Pathways, you get a bunch of key building primitives to support a bunch of different types of whatever you're doing with a training or inference. You have a bunch of developer primitives, which allows you to look at this as kind of from a developer perspective rather than worrying about it looking at just from an infrastructure perspective. And then you have reference implementations of ways to manage the life cycle of training or inference work. When you're working at AI problems, one of the things you're going to find out is data is the new fuel for that, right? And so it's really important to have high performance storage that meets the specific requirements for the AI workload that you're working on. And especially when you're working at scale, training, and inference, you need readily available data to operate at peak efficiency so you can drive the innovation. So for block storage solutions, these are some of the existing things. We have our HyperDisk family of products, Extreme and Balanced. We also have local SSD. For some of the object and file storage solutions, we have cloud storage, file store, and managed Lustre. So some of the new things that we've made available is really driven by the typical storage requirements we see for AI and for workloads. You need terabytes, petabytes, or exabytes, right? So it's not a small amount of data. You need terabytes per second of throughput, writing and reading. You need millions of requests per second, and then you need low latency for reads. And then also you're going to have spiky traffic, because especially training jobs, right? Because stuff is just going up and down, so how much throughput. So let's just be honest, GPU capacity is not available across the world easily. So it's really essential to be able to co-locate data with the compute resources wherever you may find them for the work that you're doing. So one of the things we've launched is Anywhere Cache, which is a fast local SSD backed managed cache that can deliver up to 2.5 terabytes per second of throughput and 70% lower read storage for accessing stuff in cloud storage. The way to think of it is that it's a localized cache that gives access to VMs in a specific zone, high throughput and low latency access to things in cloud storage. You pay for only what you use, and 70% of the customers with multi-region buckets will see cost benefits because you're doing less operations because of lower latency and higher throughput. We also introduced rapid storage, which is in preview right now. It integrates with Cloud Storage Fuse, and it gives you up to 20 million requests per second for objects and up to 6 terabytes per second of throughput. And most of the features of cloud storage works. In fact, it's best to think of rapid storage as kind of like another storage class for Google Cloud Storage. So you can see how much lower latency for random reads and appends, and how it's 20 times faster than regular cloud storage. And like I said before, you just think of it as any other cloud storage class. It supports most of the features for cloud storage, like API access, authentication. It's easy to move data from multi-region and with a storage transfer service into rapid storage, and then you pay for what you use. It's in private preview right now. Contact your account manager, or maybe we'll send you an email after this event. You can also use that to contact us as well to make use of, to get access to the private preview. Let's talk a little bit about high-performance parallel file systems. One of the reasons why you may end up using a parallel file system is, for example, you're onboarding to the cloud. You need to ease the migration of on-premise or bursting onto the cloud. You have high I/O and high throughput requirements, small files that would saturate a single VM's network links. And you want to optimize TCO by being able to keep accelerators busy, because they need access to the data quickly, or else you're basically spending for GPUs that aren't doing anything because they don't have the data yet. So we've had our Google Managed Lustre available now. It supports 1 petabyte of capacity and less than 1 millisecond of latency and 1 terabytes per second of throughput. And that's a zonal storage solution. But now we have Parallel Store, which is another part of our Managed Lustre family as well. And that gives you very high per VM throughput, consistent performance for a few thousands of, so think of this as read performance for thousands of VMs to the same data. And you can use it as scratch or persistent storage of offering terabytes to petabytes. And it's fully POSIX compliant, and there's a CSI driver to make use of it in GKE. So this is an overall picture of what your options are for cloud storage, for accessing, for running high-performance workloads. You have our Cloud Storage Fuse. You have Rapid Storage, which allows you to hydrate from cloud storage quickly. Anywhere Cache, that makes cloud storage available with low latency access within a specific zone. You have Parallel Store and Managed Lustre, which you can use for scratch or persistent storage, which allows up to petabytes of capacity and ultra low latency. So let's talk about what's new in the Hyperdisk family of products. So Hyperdisk has always been built for the different types of workloads that you have, and it supports either individual VM or pooled access. And the pool model allows you to control, manage the amount of storage and access to your storage at a pool level rather than an individual resource level. And then you also be able to choose the performance at the pool level as well. So what's next for Hyperdisk is that we now have exascale pools for Hyperdisk. Hyperdisk ML was always the fastest way to load your accelerators, right? And it's 3 to 6 times faster than any other storage in Google Cloud. And now some of the things that we've announced since next is you can attach Hyperdisk ML to any 4th gen processors like the C4A. And we're also working on automating hydration from cloud storage to Hyperdisk ML using GKE. So exapools, which is what's new, came after next, is block storage for exabyte workloads. It supports exabytes of capacity and up to 5 terabytes per second, or for simultaneous throughput. It's thin provisioned like some of the other pool products that we have for HyperDisk, and the data is reduced, meaning it doesn't equal to the amount of storage as much as you're using. So there's some compression in the background there, and you manage it from one interface. And the preview is available this quarter. So now you have kind of like, when it comes to HyperDisk family, you kind of have a choice as to how you make use of the resources. You can use standalone volumes for things like HyperDisk Extreme. You can also use storage pools for HyperDisk Balance and Throughput and HyperDisk ML. And then you can use exapools now for HyperDisk ML, which supports up to 2.5 petabytes. So this gives you kind of like a bunch of different options when it comes to HyperDisk, depending on what type of workload and what type of latency and throughput requirements you have. So now that you have this full suite of storage and compute resources you can use for your different AI workloads, you'll find that managing AI workloads on thousands of resources is going to be a challenge. And so you have to kind of change and shift the way in which you think of how you use AI. And this is why the whole concept for us of the AI hypercomputer comes into play, because you need to have seamless orchestration and advanced networking that allows you to basically operate everything as a single unit to be able to maximize efficiency for running your AI workloads. So some of the requirements that you're going to have is you need to have automatic resource provisioning so you can dynamically allocate and deallocate resources. You need to simplify your cluster management. You need to have intelligent workload scheduling so you can have resources used all the time, especially if you're having commit usage for them to be able to maximize your TCO. And then you also need to have proactive monitoring so you can support things like self-healing, addressing performance issues, etc. So we already spoke a lot about Cluster Director and some of the things that it provides, but I'm going to spend a lot of time talking about Dynamic Workload Scheduler, which is another way in which you can orchestrate compute resources for your hypercomputer. So Dynamic Workload Scheduler now supports the use of TPUs and GPUs, so you can make use of that to make use inside of your cluster. Now Flex Start, which has existed for some time now, allows you to do up to 7 days with a pay-as-you-go model. But now we've launched calendar mode, which allows you to do up to 90 days. Flex Start, like I said before, gives you up to 7 days and gives you great savings for the different types of instance types. And now also supports TPUs. But now one of the things we've launched since next is Flex Start in GKE compute classes, which allows you now to do Flex Start and as a compute class inside of your declarations for GKE. This is really well suited for your inference workloads. FlexStart now also supports the A3 high machine types. And then I mentioned before, we now have DWS FlexStart for TPUs as well. So your workloads don't have to consist of just GPUs. You can also use TPUs. Calendar mode is in preview right now, and then you can sign up for access using that QR code. You need to perform training for up to 90 days. And then it gives you a guaranteed start time and a short-term reservation or up to 90 days reservation. And it also supports A3 Ultras, A4s, and cloud TPUs. So managed instance group is another way in which you can manage your resources. It's auto-healing, multi-zonal, auto-scaling, auto-updating, and flexibility.
Thinking about accounting rules.
Just a reminder, folks, if you want to ask questions, you can put them in the chat, and we have time at the end of the sessions. All the presenters will be in the chat room to be able to answer questions, and then we have 15 minutes towards the end where we can answer, where all of us will be available to answer questions as well. So one of the things that's new for managed instance group is that we have instance flexibility, which allows you to improve the reliability and scalability for highly demanded hardware. You basically can configure different VM types and then have preferences. And so that managed instance group will then manage the resources that are available based on your preferences. So if you select this type of preference and it's not available, it'll go to the next type of preference. And so it'll make sure that you have capacity, and it'll find instances to meet your capacity demands based on those rules. So titanium, which is the next topic I want to talk about, because it underpins a lot of the technology that I've talked about so far. So titanium is actually a technology that's been developed by Google for quite some time, and it allows you now to run on the same infrastructure that's been used for Google products like Search, YouTube, Gmail, and Maps. So some of the benefits of Titanium is that it allows you to make best use of TCO by offering high throughput and low latency. So you need less time to run compute intensive workloads. It has support for block and local SSD storage using Titanium local SSD and some of the latest generation hyperdisk products. And then it gives also very high network throughput. So that's what's underlying our Titanium ML adapter, which is used by our NVIDIA GPU types. So that supports up to 3.2 terabytes of GPU to GPU traffic. And we'll talk, which is what we call it cloud RDMA or cloud remote direct memory access on Titanium. So like I mentioned, Titanium ML Network Adapter is actually what we use to implement NVIDIA Connect X7, which is a RDMA over converged Ethernet, and it's integrated directly into our network fabric. So that's underpinning, if you're trying to cluster a bunch of different GPUs together, that's how you'd be able to implement it with the Titanium ML adapter. And that's support for A3 Ultras, A4, A4Xs, and the RTX Pro 6000, which is coming out later this year. So one of the big things about Titanium actually is that unlike computing approaches that only offloads and accelerators on the host, Titanium actually offloads onto other resources, so you can actually expand into resources to support your storage and networking needs. So this allows us to actually scale performance more than what's possible with just a single host. So Titanium ML is what supports our GPU to GPU communication. So it offloads processors and integrates GPUs clusters into what's known as our Jupyter data center fabric. Titanium local SSD, which is available with Z4 to C4A, gives lower latency, lower access latency, and 2.4 million random IOPS, a tremendous boost in how many IOPS. So let's spend a little time talking about the platform path. And for folks joining, we're running a little late, so give us another 10 more minutes before we start the next session, actually. We believe Kubernetes is, when you're running generative AI, the GKE is one of the best places to run Gen AI on Kubernetes. So one of the launches we made to support that is Inference Gateway, which is designed for being able to do rapid deployment of inference solutions on GKE. It gives you a simplified interface, real-time performance, low latency inference, and also quick start templates for configuring common AI models. And then it's also scalable. It scales inference endpoints to meet your demanding and optimize your resource utilization for inference workloads. We've also announced Ray Turbo. We work directly with the Anyscale to come up with a high-performance implementation of Ray. KubeRay has been available on Kubernetes for some time now. You can actually configure it in the console to make use of KubeRay. But now we've announced Ray Turbo, which is basically a specialized version of KubeRay that gives higher performance, faster iteration for accelerating your AI development cycles, scalable. It simplifies management, and then of course the big issue for is the higher performance when compared to just a regular KubeRay on GKE. GKE Autopilot has also had a tremendous amount of improvements to support the different types of workloads. Automated resource optimizations have been made. We've also improved the pod startup times. We've optimized resource allocation to make sure that your workloads are being able to receive the precise resources they need. We've made better integrations with stuff like MIG to be able to support different types of scaling, et cetera. And then we reduced the operational overhead by incorporating things like I mentioned, Ray previously, and now Ray Turbo. So one of the things that we've announced is that, and this is that Autopilot resources are now available as pods inside of GKE Standard. So what that means is that in GKE Standard, you'll now be able to not only manage your own node pools, but also make use of Autopilot resources as some place where you can send work to as well. So some of the advantages of this is it's cost effective. It simplifies your management because you don't have to manage the node pools for these as you would with a standard node pool. It also gives you consistent experience. So you can have a workload that basically makes use of Autopilot and then also makes use of standard using Autopilot nodes. And then it's optimized for containers for all the different types of use cases that you would make use for Autopilot for. You can then leverage that with standard as well. Something we also announced is you can use VLM for hosting models on TPUs. So what that does is it gives you another option for hosting models on not just on GPUs, but also on TPUs as well. So it's an accelerated, it accelerates the development of LLM solution. It simplifies your operation. It's scalable because it now uses TPU rather than GPUs. And then it's really cost efficient in comparison to GPU resources. So this is kind of like my favorite stuff to talk about here at Google Cloud, which is our app development stuff that we've launched since Next. One of the big ideas, and this is, I mean, there was an announcement just yesterday from Cloud, for example, that it's one of the hot topics is trying to go from idea to full stack leveraging Gen AI. And that's really the idea behind the Firebase Studio and Gen Kit, which is how do you transform your ideas into a full stack app quickly as possible? So some of the key launches that came out of Next was Firebase Studio, which is our agentic IDE for full stack AI apps. GenKit, which is our open source framework for AI powered app flows. Firebase app hosting, and Data Connect, which allows you to connect data from different sources into Firebase. Vertex AI in Firebase with Live API, and then the app prototyping agent, which I'll do a quick demo of a little later. So Firebase Studio is an agentic workspace to build, run, and manage web apps. As you can imagine, as a developer, this is one of my favorite things that came out of Next. It's a web-based, so you start out with a URL, firebase.studio. It's built on VS Code, so it's standard compliant, so you're probably familiar with the user interface already. There's a full cloud VM underneath it, so it supports a bunch of different tool chains. It's a pre-configured environment, so you can start from common starting points, or you can start from just using GitHub, for example. It's AI assistance built in for across code, test, debugging, etc. And then it also has a live preview, which supports emulated devices or hosting in an iframe. And then it has deep Google integration, so you can streamline your app development workflows by leveraging Google Cloud Services directly in it. And then another big thing is it's designed for collaboration, so you can have multiple developers working in the same workspace. So let's do a quick demo of what you can do. And before I jump into the demo, I'll just highlight, I didn't show the actual app running, but the app does run. The only thing you need to do that's not shown in this demo is you need to add the Gemini API key. And once you do that, you can actually chat directly in this app demo. So let me demonstrate Firebase Studio for you real quick. So that's the URL. And then it's in preview, so you can say try. I mean, obviously it'll be different once it launches. So let me give you an idea of what's possible. So I already have a prompt that I've tried before. But here I go. I'm just going to ask for it. And the initial thing it's going to ask for is to try to prototype. You can also import a repo to start with existing code. But let's start with my prompt and see where we go. And this is obviously happening in real time. I'm not going to speed this up. And you can literally see as it's thinking. And now it's told me, basically giving you some things about what the design of the application can give, things like color and stuff like that. And then it's, because I've specified Gemini as a part of it, it's going to use GenKit as a part of it. And then with the UI, it's telling what it's going to use for UI. So now let's prototype this thing. You can obviously, you saw the edit thing there. You could actually modify this if you wanted to change things. So now it's actually going to prototype the app. And this is actually one of the parts, since I've done this before, it's actually one of the parts that's going to take the longest one, which is where it's going to like do some guessing about what the main app code is going to be like. But you can already see there's already a bunch of different files that have been created already. Including this blueprint file, which gives like an idea about the core features of this thing. And then it actually gives the code that it's going to use to ingest the fact.md file that I mentioned. And it's actually going to generate an fact.md file for me as a part of this. And this is literally what I started with. I highly recommend, if you haven't tried this out yet, give it a try and just see what is possible with this platform, because I'm going to pretty much make the assumption that it's going to be a very interesting experience whenever you work with this. Obviously, you see up here, you can already publish Um, but it's not enabled currently to preview. All right. Yes, someone asked if we're going to do a recording of the session. Absolutely, it will make it available. Oh, let me see if I can rearrange the. All right, so GenKit is our open source framework for AI application development. It's open source, and it gives you a structured approach for how you can build a Gen AI application and basically hide some of the underlying abstractions of how it comes to actually making an agentic based application. You saw there for the demo GenKit, because I specified Gemini, that Firebase Studio automatically included GenKit as a part of it. So some of the challenges that folks experience once they're trying to develop agent application is the high learning curve. You have to do new testing and debugging. And that's kind of why GenKit came about. It supports a bunch of these different languages. It has a plugin, so you basically can support an ecosystem of AI capabilities. And then it's built into a bunch of dev tools, so you can do rapid experimentation and debugging. So for Firebase Studio and for GenKit, you have a bunch of deployment options. You can do Firebase, which is app hosting, cloud functions for Firebase. You have Cloud Run or GKE, and really any container platform can also be used for deploying Firebase Studio's apps. Firebase Studio app hosting is also one of the things that's available. There's also what that does is fully managed hosting with CDN and scalable content delivery. Real-time data synchronization to keep your ad data consistent across all the platforms. We now also have Data Connect, which integrates and synchronizes data across sources, for example, Cloud SQL databases and Firebase. We also have streamlined deployment, so you can deploy apps from Firebase directly out to Firebase app hosting. We also now have Vertex AI and Firebase integration, so you can use Gemini capabilities via live API inside of Firebase. So one of the things I didn't spend too much time talking about, but that actually demonstrated app prototyping for Firebase Studio, which allows you to generate functional, and this is really, really key here, functional prototypes from your specification. You can also start from, you don't have to start from scratch. You can also start from an existing GitHub or GitLab, and it basically streamlines the design and reduces the manual effort for coming up for validating a concept. It's really quick to be able to develop an app this way. So really the big picture, the next thing I want to talk about is really the universal toolkit of things that Gen AI makes available for you as an app developer or as a developer in general across Google Cloud. Gemini-powered AI assistance is available pretty much across all the platform. You have a bunch of different Gen AI-powered tools that what they allow you to do is code faster, troubleshoot smarter, and manage natural language in a much more consistent way. We have Gemini Code Assist, which includes things like agents, Kanban board. AI-powered agents allow you to do things like routine coding tasks, enforcing coding standards, etc. The Kanban board allows you to visualize your project progress and track tasks. And then Smart Task Prioritization has AI suggest the optimal task sequences and highlights to keep projects on track. There's Gemini Code Assist in Android Studio, which is just like it sounds. This is built into the IDE. And then here's what some of those integrations look like. So you have IDE integration with things like VS Code, IntelliJ, and Android Studio. You also have API integration, which allows for custom integration with existing tools and supporting things like, for example, version control systems like GitHub, GitLab, and other version control systems. And then it also allows for connecting with Google Cloud and other services for streamlined deployment and monitoring and debugging. So one of those features is what's known as Gemini Cloud Assistant Investigation. And what this does is it uses Gemini Cloud Assist to analyze cloud data, logs, and metrics to identify anomalies. And I'll do a quick demo of that now. Let me show you what you can do with cloud investigation. So the quickest way to find is to just type investigations in the search bar. And then you go ahead and say create. So I'm going to do this based off of a resource. In this example, I'm going to have it look at a firewall rule. And then I'm going to say I have a specific error message. And then I create the investigation. So what it's doing is it's looking at the resources that we mentioned, and then it's looking at the error message, and then it's using the LLM to basically analyze the resources that we have, all the configurations of the resource, as well as look at the error message that we're getting back from here. And so this is a firewall rule. Okay. So this is actually a quick investigation to run, but what it says is, so this is an internal project, so I can't have it actually world readable. And it's actually come back right away and said, hey, this rule doesn't allow traffic from anywhere else. And so that's just an example of some of the stuff you can do. And you see it actually gives you recommended fixes and some documentation. But that's the type of thing that you can do with Cloud Assist Investigation. And it can actually do far more complicated investigations. This is just one I demonstrated. So one of the big capabilities that we're trying to enable with the Gemini stack is that we're trying to give you centralized hubs to visualize the resources you have running across Google Cloud. One of the big efforts for that is the App Hub that's been around for a while now. But now we've announced increased integrations with Gemini in that. So Cloud Hub now gives you essential insights into what's going on across your resources. And now it provides AI assistance to achieve your goals. And we've now come up with a standard for defining an application and what it means for an app to be hosted inside of Google Cloud. So you can then leverage Gen AI to help you define apps, oversee apps. So application monitoring is one of those capabilities that you need to be able to support complicated cloud workloads. And so that's one of the focus of one of the things we've launched, which is App Hub now has a definition for what an app looks like in terms of services, workloads, and applications. And now once you have that App Hub definition, App Hub is able to automatically label underlying resources and then come up with a data model. And then that allows you now throughout your Google Cloud resources to be able to understand what observability across those resources mean. And it can actually appify your signals to give you metrics, logs, and traces that can then be used to drive how you generate information out of this. And the big picture of it is that it now gives you a centralized way to monitor things across your app, not just thinking of it as a collection of resources. So all signals from your underlying resources get labeled and automatically, and then no more manual maintenance of this to basically see what your app is doing inside of App Hub. Another thing we've also launched, which is to do app testing using Firebase app distribution. It basically allows you to do things like integration with your CI/CD, tester management, and then automated crash reporting. And also allows you to share builds quickly with testers. So that's another way where you can have an end-to-end development of an app using Firebase Studio and then also testing it, and then also monitoring it inside of App Hub. So we always talk about adopting Cloud FinOps because it's how you manage resources, and we've already had built-in tooling for this. We're expanding on this, which now the ability to detect billing anomalies out of the box inside of Cloud Billing. So that's now in new capabilities. And so we've also launched FinOps Hub 2.0, which is our new iteration of FinOps Hub, which gives you multi-project access, and it also now comes with built-in Cloud Assist for FinOps. Storage intelligence is also one of our new capabilities, which allows you to analyze your cloud storage usage and make recommendations for classes and how it gives you insights into how your data is being accessed and what we recommend for changes to maybe storage types or maybe location of data, depending on how folks are doing it. It essentially allows you to eliminate manual management of storages and free your teams from actually having to monitor resources to make sure it's effectively used and your cost is maximized. Something else we also announced was the Google Developer Program, which is this new, it's essentially a new way in which you can make access to resources in Google Cloud. They have different program plans, but basically it's a per seat license and comes with a pre-built bundle of different cloud services. And we think it's one of the quickest and easiest ways in which you can allocate Google Cloud resources for developers to use to come up with rapid prototyping, et cetera. So now we've kind of given you a lot of different choices overall inside of the cloud now. You can either have the ultimate control with infrastructure, or you can have the simplicity for platform. And the main theme so far that I've been talking about is, of course, the AI hypercomputer and how you can have hardware and software to optimize your AI workloads. We've talked about some of the next-gen compute resources that are now available. And then we have the high-performance storage, and then overall how you can do orchestration to manage all of these complications. And now we've also talked about distributed cloud and how you can make use of those resources on-prem. So now it's kind of a call to action, right? Now we've got all these new amazing capabilities you can now do with Google Cloud. And so what are you going to be able to do with all of this stuff? And what things come to mind in terms of what you're now able to do? So I want to thank you for this time, and we're going to transition right over to Lia's presentation for Cloud AI for those folks who've been waiting for that time. So thank you so much for your time. And I'll be on here for answer additional questions. And of course, we'll send an email out to everyone who's attended so that we can have further questions answered for you.
Okay, great. Thanks, Len. Hey, everyone. Great to meet everyone. Really appreciate you just taking the time to kind of join today. I'm Lia Passaglia. I'm an AI customer engineer with Google Cloud. So I'm based out of Atlanta. I've been here for about 3 years now. Definitely exciting stuff, especially with the rate AI is moving. So just super excited to dive into everything today. So for this session, we're going to explore some of just like the freshest AI updates and releases on GCP. Really, my hope is to kind of just give you insights to hopefully spark ideas and how you can leverage kind of the latest features to solve maybe new challenges or unlock current use cases that you've been building with. So just given the rapid pace of which things are developing, especially with announcements from Cloud Next, I/O, we have a lot of new stuff out there. So I'm trying to basically provide a concise overview of some of the most impactful stuff. We definitely won't cover all of it today, so highly encourage you to check out blog posts, YouTube channels, official docs and stuff to dive deeper, but I'll go ahead and jump into it. So to kind of start off, if you look at like how Google Cloud organizes its kind of AI portfolio as a whole, you can kind of organize it into 3 kind of key layers. The first is our kind of foundational AI infra side. That's a lot of what actually Len spoke about today. And then we have our kind of Vertex AI platform, which is kind of our robust end-to-end platform, kind of in the middle. And then on top are AI applications, which are kind of out-of-box offerings. And this includes a new exciting offering called Agent Space. So for this portion of the session, we're going to focus mainly on Vertex AI and Agent Space. But do remember that all of this basically runs on Google Cloud's powerful infrastructure like GPUs and TPUs, and those are available directly to you as well. So Vertex serves as our end-to-end platform for all your kind of AI use cases. It consolidates kind of a variety of the tools, models, and services on the platform and can kind of, again, break it down into 3 core areas. The first is Model Garden, which is basically a library of models. It has our pre-trained Google first models, as well as open models and partner models. Then we have what we call Model Builder. This is really all the tools and services for model customization, development, and deployment. And then we have Agent Builder, which is really for creating AI agents. Then building on top of Vertex, we have AI applications, which are out-of-box offerings tailored for specific use cases. This layer is going to include Agent Space, which is a new tailored offering, really geared towards basically sophisticated enterprise search capabilities and powerful AI agents for internal employee use cases. So we'll talk about that more in a second, but really the goal is to help make your employees faster, smarter, and kind of more impactful in their daily work. So kind of diving deeper into each of these sections, basically Model Garden, like I mentioned, it's a library of models where you can kind of come to discover the right model for your use case. So that's something like Google's new Gemini 2.5 models or our Gen Media models, or it could also be, the latest releases from partners in the open source community on Model Garden. So very cool and exciting big update is that we just launched our latest family of models, our Gemini 2.5 models, with Pro and Flash now being generally available. So these are our most intelligent models yet. They're really distinguished by their advanced thinking capabilities. So what this really means is that they can show their reasoning step by step. And this overall one provides just greater transparency, but it also makes it easy, makes them more capable to tackle really high complex problems. It's improving their accuracy a lot. And that's just allowing you to kind of build smarter, more context-aware agents with optimized performance as well. And so we're really seeing this stand out across all industries, even in highly regulated sectors like healthcare and finance, because of just the enterprise guarantees that Google as a whole provides on our AI solutions. And they're allowing them to build more capable, transparent, and kind of cost-effective apps. And so that, looking at kind of each of these models, 2.5 Pro is our flagship model. So this boasts kind of inherent thinking capabilities, and this is really your go-to for peak model quality. Particularly, it's good for coding, vast world knowledge, and like general complex reasoning tasks. The next is our 2.5 Flash model. This is a kind of our workhorse of models, and it offers configurable thinking capabilities. So basically, you can configure how much you want it to think, and it's going to be built in for stellar performance. And so 2.5 is going to be kind of your go-to for daily tasks, things that are you want fast enough to power real applications, but aren't too complex that you'd have to go to a Pro model for. And then lastly, we have in preview our 2.5 Flash Lite models. This is really your ultimate choice for speed and cost efficiency. So think of it, its thinking capabilities are also configurable through, though they're kind of off by default. And so it really just makes it perfect for high volume, cost optimized scenarios is when you might turn to Flash Lite. So hopefully you kind of see the theme here, but basically the 2.5 family really gives you the flexibility to select kind of the precise balance of intelligence plus speed and cost, kind of depending on the use case you're exploring. So how might you kind of make the most of these models and choose the right one, potentially at every single query at scale? That's where Google introduced what we call Model Optimizer. This is a new feature in preview, and it's basically a managed endpoint that will intelligently route your prompts to the most appropriate Gemini model. So whether it needs more high accuracy, we'll go to the Pro, or cost efficient, so it can go to your 2.5 Flash. And it's going to do this automatically based off of predefined preferences that you set. So it's going to overall simplify model selection. You don't have to manually choose which model for each query. And it's going to provide overall cost quality optimization, so you can kind of balance performance and your own budget requirements. Another cool, exciting launch within the kind of our Gemini announcements is our latest updated version of the Gemini Live API. If you're not kind of already familiar with the Live API, this is a model that can basically see, hear, and speak, and provide swift natural responses back. And so it's a really intelligent endpoint. It was originally powered by Gemini and our latest Chirp 3 audio model, which is now GA. And so you can really build production-ready, robust solutions that are these real-time interactive audio and video experiences. If you're familiar with Project Astra, that's kind of the types of experiences that you can build out. The new endpoint that we just released into preview is kind of an evolution on top of the GA endpoint. And so this preview endpoint actually integrates native Gemini audio, and this is significantly seeing enhancements in voice quality and delivering a more natural experience. And so it has two kind of cool new things: the proactive audio, which means that it's able to kind of intelligently filter out the audio that's coming in. That way it's only responding to like the input that's pertinent to the actual conversation, and the responses are timely. And then it also has affective audio, meaning that it can perceive and adapt based off of what the user's input expression is, or how the emotional tone is. So if it's sarcastic or excited, and then it can kind of adjust its response style from there, overall delivering more rich human-like interactions. And so if you're interested in kind of building out these real interactive video experience, and that's a use case, definitely recommend checking out the Live API. If you want to go to production with it, we have that GA endpoint. Otherwise, we have these new preview ones as well, which will give you more voice quality improvements. So kind of going beyond our core Gemini models, another incredibly exciting area of innovation for Google AI is in Gen Media. And so we're going to shift our focus kind of to these three models, our latest Imagine 4, Veo 3, and Lyria, which are for image, video, and audio respectively. So looking at Imagine 4, this is currently in public preview, and this is really our latest advancement in text-to-image generation. And it's definitely setting kind of new benchmarks for quality and control. You'll see kind of on one of the images, you can see that invitation. So Imagine 4 is really outstanding at text rendering. So it's going to deliver clear, readable text within the image. And it's robust multilingual support. So you can write prompts in different languages, and the model is still able to understand it and generate the image. And it's going to overall just deliver quality improvements across virtually all styles that you're prompting for, whether you're aiming for photorealistic, artistic, or more stylized images. What's also really powerful about Imagine 4 is that it's available in a multiple of variants. So like kind of like the theme of the Gemini models, Imagine 4 has Imagine 4 Ultra, which is going to be best in class for the actual image quality, as well as Imagine 4 Fast, which is going to be exceptional for speed. That's kind of enabling you to kind of perfectly balance, again, performance and cost for any image generation tasks that you may have. You can kind of see a few of these examples on the slide that were generated with Imagine 4. The top left, you can see it can kind of produce more like comic strips and things like that, but it also has the ability to produce really high fidelity, complex scenes, photorealistic images of like humans and people, as well as product visualizations like the perfume as well. So now moving to motion, Veo 3, which is our video generation model, is currently in private preview. This is really also taking kind of the industry by storm because it delivers dramatically visual quality. It also has a stronger grasp on like real world physics, thus the videos and the content in them feel more realistic. And then it has superior prompt adherence, meaning what the user prompts, the video is more likely to actually adhere what it generates to. And new features is that it integrates full speech and full audio capabilities, so music, sound effects that can be directly kind of generated within the video. And so really a big game changer for content creation, especially in marketing, media, entertainment industries. So I'll go ahead and play a few of these samples here. So you saw that one. That's more of a cartoonish video. The music that got generated was light, upbeat. And then we can kind of show this one.
We need to find a solution that benefits both of us.
Okay, so you can see that one's a little bit maybe more cinematic. It has darker moods and lightings. The music's a little darker as well. And so it kind of shows the range of which, with some prompting, you can get videos generated by. So rounding out the Gen Media models from Google, we have Lyria 2. This is text to music, and this is now GA, so generally available. You can generate high quality, royalty-free instrumental music clips. These can go up to 30 seconds directly from your single prompt. So something like, hey, create Irish folk music with fiddles and bagpipes, and Lyria is going to kind of generate that distinct musical piece. And so it has powerful things around customizing the mood, the genre, the tempo. And so really you can create the right music to match your project. And so again, content creators, game developers, advertisers, we're really seeing all of these models take those industries by storm. So we touched on mainly a lot of, these were all Google first models, but a core philosophy to Vertex and something that we've been very committed to doing is providing you with the maximum choice. And so we firmly believe, having the right model for the right job at the right time for your use case is really the key to your success. And so that's why Model Garden kind of continues to expand rapidly with third-party and open source models. So you'll find all the latest offerings like Claude 4, Llama 4 from innovators like AI 21 Labs, Anthropic, DeepMind or DeepSeek, Meta, Mistral. And so these are all now directly available within Model Garden. They see significant updates as those partners update their models, and it's shown on Model Garden. So expansion really doesn't stop there. We're continuously adding new models to the platform from other organizations like Ham AI and Quoto. And we have an existing partnership with Hugging Face for all their open source models to be delivered on the platform. And so definitely encourage you to check out Model Garden, just see all of the latest models available on Vertex for you to be able to utilize. So we've kind of explored the different models and what Model Garden offers, but sometimes you need to build, fine tune, or deeply customize your own models. And that's where we would traditionally look to Model Builder on Vertex. So we'll look at kind of the latest updates on how to customize, evaluate the performance of, and ultimately kind of deploy your models. So following up kind of on an earlier discussion that we had around the 2.5 models, basically the 2.5 models allow you to have the thinking capabilities. And so a key thing to really customize and control the model is what we have called thinking budget. And this feature allows basically you to customize the model's reasoning process, thus giving you direct control over how much thinking the model performs. By default, the 2.5 models use dynamic reasoning, meaning that they're going to just intelligently adapt how much thinking they should do based off of the complexity of the task. However, you can set a specific budget. That way, you're kind of allocating more or fewer resources to the model's reasoning, and thus kind of directly impacting the cost or the latency of the model's response. And so maybe for a high complex task, you're going to set this budget really high. And for a very simple task or high volume task, you might set this budget very low or almost basically zero if you want the thinking capabilities completely turned off, which is possible for the Flash models. So really this level of control really just ensures you have that kind of precise balance again of accuracy, speed, and cost, around all the different applications that you're building. So another recent launch was the global endpoints of our Gemini models into GA. And so all our latest models basically provide capacity-aware routing across global regions if you use the global location when you interact with the model. So really the core benefit here is that the endpoint is going to automatically load balance your requests, basically allowing you to kind of seamlessly leverage Google's global infrastructure. And it's going to overall give you, high availability of our services, increased reliability of the model's responses, and then ultimately reduce errors. I mean, especially if you're using the models on what we call dynamic shared quota or PAYGO, meaning that you haven't subscribed or purchased dedicated capacity for the model and you're using kind of a shared pool. Using the global endpoint can further reduce errors because we'll load balance to regions with availability when you use that endpoint. And so overall, just a more smoother, robust experience for end users. So when it comes to customizing pre-trained models, like Gemini or even the third-party and other open source models on the platform, Vertex as a whole offers a spectrum of powerful methods. Obviously, with Gen AI models, you have foundational techniques like prompt design to guide the model's behavior. You have grounding and long context, which is going to allow you to inject your first-party data or additional context into the model to further enhance its response and reduce hallucinations. Google has some unique services around grounding systems specifically. So I recommend you checking those out. Things like grounding with Google Search, vector databases, and RAG systems on the platform that you can be utilizing to create grounding, as well as Gemini is one of the models with the longest context window, so you can really be capable of doing long context and further enhancing the models. But those are kind of techniques available across most foundational models, is going to be prompt designing, grounding your models. But then when we look to kind of further enhance models, sometimes tuning the models are needed. And so we have what we call supervised tuning. And so this is the first kind of maybe lever to pull, especially if you're using a foundational model like Gemini. And what it's going to do is help kind of tweak the model to your specific domain or your specific task at hand. And basically you provide input-output example pairs. We've had this for our previous generations of Gemini models, and we just launched this for Gemini 2.5 Flash. So you'll be able to do supervised tuning on 2.5 Flash and really tailor this workhorse model more to your needs. And then lastly, when you look at kind of the deepest level of specialization that you can get with models, we probably look to full fine tuning. And that allows you to actually update the model's weights directly and thus incorporate new knowledge, make it highly accurate for specific tasks. And this is really going to be for open weight models on Model Garden. So things like Llama, foundational models that don't expose their weights are not going to be able to be full fine-tuned, but we have a lot of different models on the platform through Model Garden that you can fine-tune or fully fine-tune. And you'll actually see sample recipes and things through Model Garden when you go to work with those models, as well as you could potentially train your own models from scratch if you wanted to. And we have, again, traditional training services on Vertex to train models. Vertex AI custom training has been our traditional APIs for model training on Vertex. But we're also launching a new model development service coming soon that's going to give even more control over infrastructure while still being a kind of a fully managed service for training models. So overall, in that last portfolio, kind of like what I just touched on, really the goal is to make it really easy if you do choose to go down the open weight model path and fine tune these models, is to give you model training and serving recipes to really make it as easy as possible to utilize them. So you'll have tools like Workbench, Axolotl, and more, which will give you more flexible options to customize these models on your specific data sets and tasks right within the Vertex AI environment. So like I said, lots of recipes, example notebooks to help you tune these models. Then we also want to provide you with efficient architectures for serving these models. And so we've integrated with popular frameworks like BLLM, SGLang, OLLAMA, and this is all going to kind of ensure you can deploy and serve open source models, but with top tier performance and scalability on the inference side. Another cool update here is we did just launch, or we have our new 60-second fast deployment. So popular open source models like Gemma, you can actually deploy those in as few of as 60 seconds. And so basically pretty instantaneously, you can start sending requests and interacting with open source models deployed on Vertex. And that's just going to allow you to test it out, move to production faster than ever before. Another key feature is obviously when you go to use models, you want to be able to measure their performance and how reliable they are. And so we're now offering performance metrics specifically for Gemini and other foundational models through Model Garden. And this is just really geared toward giving you immediate insights into those models. We have vital health metrics that are directly available within the Vertex AI homepage. And so it's going to make it really easy to access information like usage, latency, and error rates. And so you can see all those as well with pre-built dashboards and cloud monitoring. And so it's just going to make it really easy to help spot check different issues, address problems, maybe notice that there's capacity constraints or specific errors that you're seeing, and hopefully just make you working with these models as smooth and effective as possible. So finally, kind of the last offering I'll talk about within the Model Builder Suite, definitely a ton more to possibly talk about, but I'm going to focus now on kind of evaluation. So when you go to evaluate these models, especially Gen AI models that were traditionally maybe more difficult to evaluate because their outputs can maybe be a little bit more subjective, Vertex introduced an evaluation service. This has been around for a while, really geared towards maybe individual model evaluation or evaluating two models against another. But the latest news for this service is new powerful agent-focused evaluations. So now you're not going to be able to just evaluate your models, but also your agents. And so when you think of an agent, it's doing more than just generating the final response. You're going to want to evaluate each step that the agent takes, its trajectory, maybe what tools it used. And so we've built out basically services that will work across any agent framework that you're building with, LangChain, LangGraph, CrewAI, or custom build. And it's going to be able to evaluate the agent's execution and overall performance. Then some other key capabilities, we have new multimodal evaluations as well as automated rubric generation. So this is going to basically enhance evaluation accuracy and give you more tailored rubrics based off of your use case. And then we can also now do batch evaluation as well. So just making it really easy to efficiently analyze very large data sets. And so this is really going to empower you to vet, optimize your models and your agents. And so this kind of leads us nicely into our next section, which is new launches specifically around agent building. And so looking at kind of a big area of innovation has been this kind of next layer or even a newer layer of the Vertex AI platform, which is all tools and services around discovering, building, and seamlessly deploying enterprise-ready agents. And so at the heart of Agent Builder was really our goal to simplify agent development for customers. And so our newest offerings include what we call our Agent Development Kit, which is an open source SDK for defining multi-agent applications. Then we have Agent Garden, which is basically a collection of samples agents to get you started, and Agent Engine, which is a fully managed runtime, really geared towards agent use cases that you can deploy your agents to, and it's going to have out-of-box monitoring, session management, long-term memory, so key features for agents. And so we really have created this well-lit path for discovering the agent in Agent Garden, or build your own custom agent with the ADK, and then easily deploy them to Agent Engine. And so let's dive into kind of each of these a bit more. So the ADK is a powerful open source code first SDK. It's now available in Python and Java. And so it represents actually how Google ourselves built multi-agent solutions internally, and now kind of allows you to do the same. And so it's a very flexible modular framework that's kind of abstracted away some of the concepts of agents. So you really just focus on, for each agent, defining its definition, which model it's using, what are the instructions it should follow, what are the tools it has access to, and what agents can it then pass to. And so with the ADK, you really can easily define multi-agent apps, orchestrate their actions, maybe mix in deterministic code with the GenAI reasoning. And so we're seeing a lot of customers tackle very even complex real-world scenarios pretty easily with building with the ADK as the framework. You also get to leverage kind of an intuitive local development UI when you're working with it and a client. So really quick to iterate, test, and debug anything that you build with the ADK. And then it's going to use Gemini by default as the model, but it is model agnostic. So you can use any GenAI model that you like, or fine-tuned or third-party model LLMs as the model behind each agent that you're defining. And so the ADK is going to kind of access nicely the rest of the Google Cloud and Vertex AI ecosystem. So you're really going to be able to use a lot of pre-built and custom tools that Google offers, plus extensive connections to other enterprise-grade data and systems like Apigee on Google Cloud. Like, you have a lot of tools and services that you can start utilizing to really empower your agent to bring the right data in at the right time, or take actions on your behalf against other systems as well. Baked into the ADK is going to be observability, evaluation tools, as well as flexible deployment options to scale your agent, which we'll talk about in a second. But if you want to get started, I'd point you to Agent Garden. This basically has go-to resources to build fast with the agent samples. So you'll be able to see different agents across different use cases. We have things like a travel concierge, a customer service agent, a data science agent, just RAG in general to get you started. So definitely encourage you to explore these, see the different architectures, the different components that the agents have, and they can be great starting points for your use cases if you're thinking about building an agent. And so then once you've actually have built your agent, how do you deploy it? Well, you can obviously deploy it on your own infrastructure, manage the infrastructure yourself. Or we have what we call Agent Engine, which is now GA, and it's basically a production-ready agent-tailored runtime that will let you deploy and scale your agents without having to manage the underlying infrastructure. But beyond just the runtime, it also now has critical kind of capabilities for agent operations. So things like sessions, which will allow you to store and manage kind of the full context of the conversation between the agent and the user. This is going to give you more ongoing, seamless interactions. Memory bank is a way to actually summarize data across multiple sessions. And that way, when a user comes back or returns or creates a new session, the agent can actually remember, conversations it had in other sessions with that same user ID. And so it's going to improve overall kind of user experience, really allow you to unlock really personalized interactions if you build with the memory bank. And then lastly, example store is another cool feature to highlight. And what it does is it actually allows you to store all your examples in kind of a RAG system, which is our example store. And it's going to manage few-shot examples under the hood during your agent. So real-time conversation, it will retrieve the most relevant example in your example store to enhance the prompt and thus make the agent more smarter and more consistent overall. So again, the well-lit path is to build with the ADK, deploy onto Agent Engine, and really quickly get started with building agents. They also wanted to quickly highlight our newly introduced A2A protocol, which aims to kind of enable seamless multi-agent collaboration. Google introduced this open protocol really designed to create dynamic, long-running interactions between agents. Basically, you can enable agent discovery through what's called an agent card, and that's really geared towards enterprise use in mind, so security and governance. And then you can leverage existing standards like HTTP. A2A is going to facilitate kind of a secure agent mesh where specialized agents can collaborate between each other to solve complex problems. And so if you're familiar with MCP, this is really complementary to MCP. A2A is focused on agent-to-agent communication and long-running kind of tasks, whereas MCP handles agent-to-tool interactions. And so it really goes hand in hand. We're receiving a lot of great support and contributions from partners like Microsoft and LangChain. So definitely a good protocol to keep on your radar. So yeah, so I've covered tons of tools and the platform for building agents and just overall Vertex. I'm going to touch on one of our latest AI applications in the last few minutes, which is what we call Agent Space. This is a really new, powerful AI app built on top of everything that we've talked about today. And it's really specifically designed to unlock enterprise expertise for your internal employees. And so really a key feature of Agent Space is the ability to kind of apply advanced multimodal search across your enterprise. And so it's really a game changer for how your teams discover information. Like imagine that you can search and it just doesn't understand just the text, but you can blend in images, websites, PDFs, audio, video, kind of all across your organization. And your employees can go to one place to find the critical information, despite wherever else it lives in the actual system. It actually, the search part leverages Google's knowledge graph tech under the hood. And so we've enhanced the accuracy and just overall personalizations of results that you'll get from the general kind of search and assistant. And you can even search across people within the organization. So you'll really be able to find the right data, again, find the right data for the right user and connect them to people within the org as well. And so really these capabilities get unlocked by what we call out-of-box connectors to these various third-party applications. We have a lot available today and definitely more expanding in the future. So as we move beyond just discovery, Agent Space also empowers your teams to make genuine sense of enterprise data and generate kind of immediate relevant content. And so we're taking kind of the leap from basic search to actual understanding, active creation. And so the general assistant, which is now powered by 2.5 Flash, is kind of at this forefront. It's going to deliver grounded summaries, be able to extract insights from the internal data you're pulling, and then turn those into tangible assets like one-pagers, briefing docs, whatever other content you want to create based off of that grounding source. And so last thing to touch on in Agent Space was a recent launch called Agent Gallery. And so really the vision for Agent Space is to be the AI entry point, the one place for internal employees to go to access all agents that the enterprise wants available to them. And so they'll be able to go to Agents Gallery and interact with Google's pre-built specialized agents like deep research and idea generation, as well as build their own low-code / no-code agents with Agent Designer, and then also access any partner agents that the enterprise wants to surface to their employees through the Agents Marketplace. And so those are really just some of the key features or most recent kind of announcements around Agent Space. This is currently behind an allow list. So if you are interested in Agent Space, you have that business use case of improving employee productivity, and that's top of mind, definitely reach out to your account teams and learn more about Agent Space. So yeah, with that, kind of reached the end of my section. I know I covered a ton and probably moved pretty fast, but hopefully it was a good overview that gave some valuable insights and just kind of sparked some exciting ideas for what you could do next with AI. Like I said, check out all the other resources that we have available, blogs, channels, other docs and stuff to dive in deeper. Really just get hands-on with it, follow up with, again, your account teams and keep the conversation going. But yeah, thanks again for your time. I'll go ahead and kind of pass it on to our next presenter.
Thank you so much for that, Leah. I think we've got Sean up here to present next. I'm waiting for Sean to get ready. I can actually demo the.
Hey, I'm good.
Oh, you're good? All right.
Yeah, sorry about that. I was getting myself lined up. Give me a sec here. Let's see. All right. Okay. All right. Thanks, everyone. Hello, and thanks for attending. I'm Sean Patterson. I'm a database management specialist, customer engineer with Google Cloud. Okay, so databases have always been the backbone of applications, the quiet workhorses behind the scenes that do their job without fanfare. But increasingly, we're seeing our customers move databases at times to the front of the stage, driving powerful new application features that only databases can deliver. So for the next few minutes, I'm going to walk you through a few of those key new features of our relational databases. Okay, first of all, to sort of set the stage, at Google Cloud, we have an incredible suite of databases that provide the foundation for building innovative and intelligent applications that can transform your business. So as you can see in this slide, we have a database for every need. We have structured, we have unstructured, we have transactional and analytical. Our databases support various data models, including relational, in-memory, document, key value, vector, and graph. And this variety provides flexibility for developers who choose the best fit for their specific needs. We have a compatibility with a wide range of technologies, including open source and commercial, allowing easy migration and integration. But here's the real kicker as I look at it. These databases are not just standalone silos. They're designed to work together seamlessly, and they're deeply integrated with Google Cloud's AI platform that was just discussed, Vertex AI. Now, Gartner recently acknowledged our leadership in the cloud database market for the 5th year running. Notably, they said Google Cloud had the most complete vision for cloud databases out of all the other cloud service providers out there. So we're doing innovative things with databases. And as we go through this presentation, I'm going to talk to you about some ways that you can take advantage of that. All right, so the AI era is picking up steam. I doubt anyone's shocked by that kind of a statement. It's only going to continue to accelerate. And we're moving beyond standalone LLMs to grounding generative AI applications in operational data. And increasingly, we're finding that that data is in operational databases, the ones that power our applications and are right up front with the application. So we're committed to making that a streamlined experience. So one of the primary roles that we see of operational databases in AI applications is to store and query vector embeddings. So we can do things like semantic similarity search against the data in our databases. Every single Google Cloud managed database service supports vector embeddings, every one. And increasingly, we're going beyond that, adding support for capabilities like natural language processing and seamless integration with Vertex AI, like I mentioned a minute ago. Okay, for the next few slides, I'm going to put a spotlight on one of our database offerings, AlloyDB. AlloyDB is the future of databases available today, empowering you to unify your data needs. Built on and 100% compatible with Postgres, AlloyDB is emerging as one of our best database platforms to power your AI applications, real-time analytics, or any number of traditional transactional processing use cases. Okay, so enough setting the stage. Let's get to the announcements, starting with some of the new AlloyDB AI capabilities. So generative AI applications are one of the fastest growing workloads that we're seeing our customers deploy. And you've told us that you want a database that is Gen AI enabled out of the box. And that's what we've aimed to provide with AlloyDB. So AlloyDB AI is really a suite of features that has 3 main pillars, as shown in the diagram at the right there. So we started, and this has been a while. This has been a few years. We started with a high-performance vector processing engine to store, query, and manage vector embeddings, and to do that beyond what just the standard PG vector functionality provides, but to integrate with Vertex AI and be able to tie into LLMs very easily. And we will continue to improve on this. But I do want to talk about 2 more things that we recently announced. The first is the AI query engine. So this is great. The AI query engine lets you tap into LLMs grounded in your own data with very familiar SQL. So it's new things, and I'll go deeper. I'm talking high level now. I'm going to show you some code in just a couple minutes, and you'll see how easy it is. But we've also launched or announced the natural language interface so that you can query your data much more easily in regular language. Okay, so that's high level of the new AlleyDB stuff. Let me dive a little deeper, starting with the AI query engine. Okay, so what we've done here is given you some new functions that let you call LLMs directly from your SQL code. We started this with the ability to generate embeddings on the fly by calling embeddings models in Vertex AI from SQL, right? So that was the start of it. Now, the new AI functions I want to dig into a little more, and our aim with these is to make it dead simple for database developers to write AI functionality all in familiar SQL. Starting with AI.if. Now, AI.if is a new filter function that you can use to call an LLM to do things like sentiment analysis. So notice the highlighted example here on the right. Here, look what we're doing. Here we want to see all positive reviews. So that's LLM-driven sentiment analysis. And look how simple it is. Look how simple the code is. But we're also, this is sort of a hybrid thing. We're also adding, we want to see that for well-known skincare brands. So that's fuzzy, right? That's not the kind of thing that databases have traditionally been good at. It's natural language. And that's the type of things that LLMs are very good at answering from world knowledge, from the knowledge that's just built into a generally trained LLM. And then at the end, we can throw in traditional SQL, right? Which still has its place. So in this case, we're filtering on price is less than 50. So very much a hybrid query using the best of AI and traditional SQL to get a really clean answer for our user in this case. That's it. There's no Python here. There's no linear algebra here. Any SQL developer can build AI features with ease with AlleyDB AI. So that's AI.if. Along with that, we're launching a couple of other functions. AI.rank is being launched as well to make it easy to sort query results using custom natural language instructions. And we're adding AI.generate, that just what it says, it generates text by providing data, by combining data with the user's prompt. So on the fly, you can generate text with this. The AI query engine calls Gemini models, or it can call third-party models, really whatever's in the model garden in Vertex AI. So again, our goal here is to make it so easy for SQL developers to build powerful generative AI applications without advanced AI knowledge. Okay, that's the query engine. Now, let me talk about natural language. So this, again, the same theme. It's meant to make things easier for SQL developers, right? So this goes a step further. For folks who are not developers, this gives you a way to securely respond to natural language questions of any kind. AlleyDB will just figure out the right tables and columns and so on from the context it has and from the schema that it's aware of, and it'll return the results. It's true natural language querying. Now, to complement this natural language functionality, we've also created a new security feature, parameterized secure views, that will make sure that these kinds of freeform AI queries are appropriately scoped and protected against security and privacy violations. Think in terms of the problem, the age-old problem of SQL injection and how to protect against that. This is kind of the AI generation of protecting against similar things. So with parameterized secure views and AlleyDB natural language, super easy for any user to query your database. Okay, next up, the scan index. So this is a key ingredient in the secret sauce of AlleyDB AI. So implementing vector search on large data sets generally pretty much always means you need a vector index. And there are several available out there. There's HNSW, there's IVF that are open source and standard and available. And any index, these require trade-offs in terms of index build time, index management, memory consumption, and query performance, right? There's a trade-off that's always in play there. Now, scan. This is a technology that we at Google developed many years back that powers Google search, for that matter, and other Google services. We developed it because we had to have it to do things at the kind of scale that we need to for something like Google search. So now we built scan into AlloyDB AI to address the kinds of challenges that I just mentioned and the trade-offs. So with the scan vector index, you get superior performance, much faster vector index builds and updates, and automatic index maintenance, all with less memory consumption. Scan is just an absolute workhorse, and it is the next generation of vector index technology, and available to you right now in AlloyDB AI. Okay, so a few minutes ago, you heard about MCP, Model Context Protocol. Developing agentic AI applications is new and rapidly evolving, and until recently it's been challenging to figure out how to connect all the pieces in a secure and performant way. MCP Toolbox for Databases is an open source MCP server, and it enables you to develop AI tools faster, easier, and more securely by handling all the complexities like connection pooling and authentication and more. In other words, it's just the glue that helps you tie your AI applications to your data sources. With MCP Toolbox for Databases, you can enable AI agents to securely access real-world data, real-time data, execute functions, perform complex tasks across diverse applications, moving beyond isolated model capabilities and having to code all these connections yourself. It supports LangChain, LangGraph, and Llama Index, as well as all of the Google Cloud and third-party data sources shown here, and more coming. And this is available for download today in the Google GitHub repo. So if you're building agentic AI applications with databases as a source of truth, this is a product you're going to want to look at. Okay, finally, a few minutes ago, Lia discussed agent space, so I'm not going to rehash that. What I want to tell you, though, is that just now launched in preview, Agent Space now supports AlloyDB databases. So with this launch, it's again, same theme. It's easy to build an AI agent that can answer end user questions from up to the minute data stored in AlloyDB, along with the many other data sources that Agent Space can connect to. So think about your employees getting answers to questions like, how does this morning's sales revenue compare to the average morning last year? You know, something like that, something very much real time. And which products sold the most? Or email me a list of the products that were most often targeted in attempted fraudulent transactions over the past 2 years. With Agent Space being able to connect to AlloyDB as your operational databases, these kinds of questions are very easy to get answered for your users. Now, with Agent Space connected to AlloyDB, it's never been easier for employees to find answers from real-time data and take appropriate action on them. Okay, so I'm going to wrap. That's the AI section. Some of the new things with AlloyDB AI that I wanted to cover, but we also have new features that are not necessarily AI focused, but which are still exciting, and I want to cover a couple of them real quick. Starting with managed connection pooling. Now, handling high connection loads to your database and connection spikes driven by events and things like that, this is the kind of challenge that DBAs have been familiar with forever and ever, right? An idle database connection on a Postgres system, for example, it might consume several megabytes of memory and some CPU as well. Now, what we're seeing is with modern microservices application architectures, it's not uncommon to see thousands of concurrent connections from applications to a database, and this could amount to hundreds of gigabytes of memory overhead. Now, memory, of course, is a precious resource in any database, and if applications are making many concurrent connections, the result could be significant memory consumption to make and maintain those connections, memory that we could make better use of by the system for the buffer cache and other things that databases use memory for. So we've launched managed connection pooling currently in preview. This is in preview for both AlloyDB and for Cloud SQL today. So you can begin using this today. So with managed connection pooling, you get a fully managed experience that gives you improved reliability and stability to handle events like connection spikes, and improved overall performance by reducing the amount of heavy connection overhead just routinely on the database system. Now, look at this graph, right? As shown here, a given system, this is a Postgres example, a given system might max out at around 5,000 direct connections to the database. With managed connection pooling, you're able to have many more applications connected and at much higher throughput, so you can get more out of your database with this feature. It's available today in preview, again, for both Cloud SQL for Postgres, Cloud SQL for MySQL, and for AlloyDB. And the last launch that I wanted to talk about is Axion, right? So over the past couple of years, as we've seen rapid adoption of our managed databases as the foundation really for anything, but especially being driven by the generative AI workloads that we're seeing, there's been a corresponding demand for more compute power under the databases. And so in April, we launched in preview today, and again, for both AlloyDB and Cloud SQL, our latest Axion processors on the C4A machine family. So this is Google's custom-built ARM-based hardware, and it delivers nearly 50% better price performance than the previous N series. We did some benchmark comparisons against AWS Aurora running on Gravitron 4, and we observed 3 times better price performance with AlloyDB on Axion, and over 2 times better price performance with Cloud SQL for Postgres. So whether you're running AI workloads in your databases, Axion-based C4As give our customers a great way, an easy way to dramatically increase database performance without a corresponding increase in price, right? So this is in preview now, but this is going to be a great feature. Okay, those are my database topics that I wanted to cover. I thank you very much for the time. And Len, who's up next?
I think it's Sri up next. Thank you so much, Sean. So I wanted to, while we're waiting for Sri I wanted to show my my fact bot that I created earlier from the demo. So yeah, here we go. I mentioned that this thing does actually run. So you can actually, and the one difference is it didn't actually create a fact.md file. I think I have to tune my prompt a little to make sure it actually does, because it's actually just using a constant for it. But I can, one of the great things about this interface for Firebase Studio is you can actually modify and give iterations, so you can develop things and then suggest changes, and then it'll introduced in that same chat interface. So yeah, this is like I said, highly recommend taking a look at Firebase Studio. And like I said, it's in preview, but eventually it's going to be able to support things like publishing and else. So yeah, definitely check out Firebase Studio.
Okay.
All right.
All right, cool. You can see my screen and hear me as well, right?
We can see and hear you. Thank you, Sri.
Awesome. All right. So my name is Sri. I've been at Google in the customer engineer, networking, and security specialist role, supporting startup customers for the last 3.5 years. Not them, startup customers specifically. Been here at Google for 6 years. Prior to that, I was at a different cloud provider in a similar capacity. Really excited to share some of our networking and security announcements. Apologize, the slide only says security, but I do plan to cover networking. In fact, that will be our first topic for the day. And I have 1 or 2 demos that I would like to play for you that are previously recorded. And yeah, let's get started with networking. Probably not the most exciting topic for the day, but nonetheless, I do want to cover it because it is sort of the plumbing aspect of everything we do, including AI workloads. The couple of things we announced with the networking, specifically Cloud WAN, some enhancements to the existing products like the Cloud NGFW, and a net new capability called DNS Armor. So these are the topics I'll be diving into, and then I'll also touch on a few of the platform products that we have been there for a while, some enhancements that are added to those capabilities, because I think some of them are very important for the team to know. So let's jump into NCC. NCC, for those that probably don't know, is the Network Connectivity Center. Network Connectivity Center, think of it as a single pane of glass control plane hub to exchange and manage your networking routes between your VPCs and between, if you or your customer has an on-prem network or other clouds, you can sort of bring all of those routes and be able to create a networking design patterns, to create a full mesh or a hub and spoke topology. And NCC becomes sort of the hub that controls the routing mechanism and allow for automatic routing. So up until recently, NCC sort of, when you're using NCC, can either supported all of the VPCs as it's what we call a spoke, or think of it as an attachment to the NCC hub. And then if you do have a hybrid connectivity that are exchanging routes, that kind of needs its own separate hub, and we couldn't sort of mix them together. So there were some workarounds to make that happen, but thankfully, as of early this year, we now have a single NCC hub that can take both the VPC routings as well as the dynamic routes that are coming from via the VPN or the interconnect from on-prem in different locations of your branches, etc., all into one hub, making this extremely easy to access and create a full mesh network in your network architecture within Google. Along with that, we also announced probably another new term, if in case you are not familiar with it, it's called the PSC. So PSC is Private Service Connect. Think of Private Service Connect as an endpoint in your virtual private network in Google Cloud that can give you access to a application that is potentially somebody within your organization is producing, and you are the consumer of it, and you have many of those consumers, or you may be consuming a Google API, or you may be consuming a third-party provided service as a PSC. So when you're using PSC, in the past they needed to be available, in each VPC, and if they're available in one particular VPC, the propagation of that endpoint, which is an IP address, wasn't sort of reachable from other VPCs if they're attached to the NCC hub. So in this model, for example, if you have a PSC on one of those VPCs up top, and you want other VPCs to reach that PSC endpoint, that wasn't possible. With the PSC propagation using NCC, now you have the ability to sort of announce, for lack of a better term, that IP address to the other spokes in the same NCC hub. So that way you don't necessarily have to create these endpoints and number of, you can consolidate them in one VPC and let others also consume it from the same IP address. Okay, so next big announcement we had at Next is Cloud WAN. So Cloud WAN, think of it as the key takeaway of the Cloud WAN is simplifying complex enterprise networks with a secure, scalable, and high-performing global solution. So think seamless connectivity for distributed organizations, right? So just like NCC, Cloud WAN is not a product. It is a sort of a set of capabilities that offers like a centralized management plane, simplifying control and visibility across your entire network. It does provide some enhanced security features, including consistent security policies and intelligent traffic steering to protect your data and applications. So one of the key capabilities is also sort of, provide high performance connectivity, right? So low latency, high throughput for your mission critical workloads, whether they are on premises, in Google Cloud, or in other clouds. A net new capability sort of we announced at Next that is a component of Cloud WAN is cross-site interconnect. So we had in the past, right, obviously cross cloud interconnect or just cloud interconnect for bringing on-prem to Google Cloud, cross cloud interconnect for you to connect to other cloud providers, Amazon, Azure, etc., using without having to have your own managed co-location facilities or equipment in your co-location facilities, right? So we were able to sort of bridge that gap. Now, if you some customers do have their branch sites, and if they don't want to run their own MPLS networks or any other high-cost networks, and they want to just use Google's backbone to be able to talk across those sites, that's where cross-site interconnect comes into play, right? So cross-site interconnect gives customers sort of a high-performance layer to site connectivity. This CSI, cross-site interconnect, leverages the Google's global backbone network, right, to provide that layer 2 transport solution. So this gives customers access to entire Google's massive network, including our vast subsea cable infrastructure, for path diversity and resiliency of your network connectivity. So this is massive. I get it. I understand that not all customers need this capability, but if you are working with a customer, or if you ever find a situation yourself in a need where you have sort of 2 branches across different geolocations, and you can't run your own fiber between them, and you do have an option with the cross-site interconnect. The next capability we announced at Google as part of our Cloud WAN solution is the NCC Gateway. So NCC Gateway is, we talked about NCC earlier, Network Connectivity Center. NCC Gateway, just like a VPC, it is a managed spoke off of that NCC. The goal of NCC Gateway is to simplify sort of your securing the hybrid and multi-cloud environments by integrating the cloud-native security services. For example, starting with the third-party SSC solutions, Secure Service Edge. So it also allows customers to terminate some high bandwidth interconnect attachments on the gateway. There are a couple of key use cases that enables that NCC Gateway enables the customers, right? So let's take a look at the first is a high bandwidth for branch users. Currently, if you have customers or users in the branch, they reach the SSC services directly over the internet, or the traffic may be aggregated on-prem and then exit out to the SSC. In both cases, the branch traffic is encrypted using tunnels, which could limit performance in many cases. NCC Gateway simplifies this with a high-performance interconnect on-ramp from the on-prem to the cloud, and then it routes all the traffic from branch offices or on-prem through the NCC Gateway, and eventually it can reach the third-party SSC services. So you can also extend that to your own private applications that are running in Google Cloud. So that's the second use case you're seeing, right? So if you want a third-party SSC to sort of scrub your security policies before it makes a decision to allow or disallow a particular request to go to your application, the same pattern, right? So Cloud Interconnect coming into NCC Gateway hands off the packet to third-party SSC, makes a decision, and then sends back to your app if it is allowed. Now you can extend the same capability in the third use case as you're seeing to literally sort of anything out on the internet as well, right? So you can go to your SaaS applications or any other applications out on the internet after the traffic is being scrubbed by your SSC. So Cloud Armor, again, I'll just recap what Cloud Armor is really quick, just to make sure the terminology is setting with everybody. So Cloud Armor is our advanced DDoS protection capability, along with the web application firewall capability, all in one product. So when you're using Google application load balancers, you can enable Cloud Armor on its backend, and it does provide the advanced network DDoS protection and, like I said, layer 7 protection for HTTP applications. In the past, or soon in future, you'll be able to do this, but up until now, if you are leveraging Cloud Armor, you had to create what we call security policies. Those security policies are project specific. In each project, you kind of had to sort of manage and replicate them on your own. There is no way to sort of get a hierarchical policies from the top down. So somebody could write a policy up at the organization level that says, hey, block traffic from all using the Google threat intel, right? Google block all the malicious IP addresses that Google thinks is malicious, and there is no way sort of to trickle that down to as a security rule or a security policy to all the Cloud Armor being used in your organization. The hierarchical policies kind of bridges that gap where you'll be able to sort of author some other security policies up top, at org level or the folder level, and then let them trickle down all the way to the project. Okay, so I want to talk about Cloud NGFW. So Cloud NGFW is short for Next Generation Firewall. In the past, it depends on when your journey started with Google Cloud. A couple of years ago, we had just VPC firewall rules. We can enhance the capability to saying network policies. Network policies kind of brought in a bunch of the capabilities that you're seeing here, from NGFW Essentials to Standard to Enterprise. With the Essentials, the Essentials tier, you have the ability to use the sort of stateful inspection and create your own address groups, very standard stuff that you expect from a firewall. And NGFW Standard kind of takes that to one step forward, where you're able to use the Google Threat Intel. Google Threat Intel is a set of IP addresses categorized as malicious IPs, door exit nodes, potentially other CSP IP addresses that we sort of manage and query their endpoints and get the IP addresses we manage. These are all the address groups that Google manages. Right? One key address group that might be relevant for most customers is the malicious IP address groups. Right? Google, in protecting YouTube, mail, search, all of the Google's infrastructure, we kind of have a good idea through that intel from the research teams, like what is a bad IP address, and generally considered as a bad IP. And we expose that intelligence as a set of address groups customers can take advantage of. So in NGFW Standard, you can scrub all of your incoming network packets through a firewall rule and evaluate that, hey, if this network packet matches an IP address that Google has in their malicious, block it or deny the traffic, right? So that's what the standard gives you, NGFW Standard. NGFW Enterprise sort of takes that to the next level, which is full packet inspection. So if you do customers or through either a policy or through a compliance regime, if you do have an IPS capability that you need for full packet deep inspection, that's where the NGFW Enterprise comes in. Today, that capability is provided as a first-party solution, but powered by Palo Alto's engine behind the scenes. And when you do a firewall rule, you say, this packet should go for layer 7 inspection, and you create a firewall endpoint, and that firewall endpoint sort of the technology behind that is a Palo Alto's. We do support obviously some of the capabilities Palo supports, but not all customers want to stick with just what we provide as a solution, Palo Alto. Maybe they want to bring in their own firewall product, right? So that's where the third-party network security integrations, think of it as NCI, comes into picture. So if you don't want to use the Palo, or maybe the capability that we are using within Palo is not enough for the set of security features that you are looking for, now customers can sort of manage their own set of firewalls, including Palo's or anybody else's, as a set of managed instance groups, and expose that to as a load balancer and create a firewall endpoint. And when you are, of course, you can create this architecture today, but that requires a whole set of routing changes in your VPC, including the NTC hub, and it's doable, but it is complex, right? It's complex. What this capability allows is simply write a firewall rule that says, hey, this packet should go to my layer 7 inspection, and layer 7 inspection is provided by this firewall endpoint, and behind that firewall endpoint is your managed firewall rules, right? So you don't need to change any of your routing. How it works, you'll be able to simply use it just as much as you're able to use the first party NGFW Enterprise capability. So this is an exciting feature for a lot of those network deep packet inspection use cases. The other one I mentioned earlier is DNS Armor, right? So as some of you might be familiar with it, is a lot of the sophisticated threat actors target cloud workloads for sensitive and PII data. Organizations are familiar with the fact that most cyber attacks begin with a DNS query, and securing DNS is a priority for our customers. Hence, the DNS Armor feature came into picture, right? It offers the earliest preemptive DNS threat detection of malware distribution, C2, command and control communication, data exfiltration, and other DNS-based threats. The way this works is when your workload in Google Cloud queries a DNS or initiates a DNS query, the cloud DNS obviously gets the query, and we stream the DNS logs into Infoblox Threat Defense. So this DNS Armor capability is provided by Infoblox. We stream the DNS logs into Infoblox. Infoblox sort of detects the threat if it finds any, and then sends that information back to cloud logging. And in the cloud logging, just like you would see any other cloud logs, you'll be able to sort of view the threat insights and stream that data into Google SecOps solution if you're using it, or if you have another third-party SIEM product, you'll be able to sort of stream it there for advanced analytics. The idea with this is if you have any DNS threats, DNS-based data exfiltration threats, we want to be able to give capacity for the customers to detect those as early as possible, and this is one step in the right direction for that. Okay. So let me jump to security topics, and I'll start with the platform security. The platform security, let's start with the IAM Admin Center, right? So IAM, some of you may be familiar with obviously the IAM, and in the past we had some capabilities within the IAM where you'll be able to see overly permissive roles and some other recommendations. Now we're sort of bringing all of that into IAM Admin Center as a single pane of glass experience, customized to sort of your role, showcasing the recommendations, notifications, and any active tasks that you may be working on. Sort of provides a unified view for our organizations and the project administrators to discover, learn, test, and use the IAM capabilities, providing sort of some contextual features about your environment, and some also curated guides. You don't see in the screenshot, but there will be a section right next to the highlights. It's called guides, where we're trying to bring in all of the curated videos or documentation that helps customers to see in everything that is related to IAM in one place. So it's all IAM Admin Center. It's also the place where you can provide sort of the key security controls as they evolve. So obviously, we continues to add new features. So as we add more key security controls, you'll also see them in this place. And you can also see how those security controls apply in your own environment, right? So you can sort of learn and track applications of those controls in your organization. Okay, so speaking of the authentication, we have sort of taking a secure by default stance, kind of enhance the re-authentication feature. So it is one thing to say customers take care of your most important super admin roles and enable MFA and all that. If there are things that we could do, we would do. Right? And this is one of those examples of that where we detected some 11 of the very highly sensitive IAM actions that are taken by the users, and when we detect one of those, so we sort of automatically do a re-authentication for that. So there is a 15-minute grace period between re-authentication, so we don't want to keep going back at it. But if you are taking one of those sensitive IAM actions, and if you haven't been authenticated in the last 15 minutes, you will find yourself logging in all over again. And there is an option to opt out if the customers do find this sort of not optimal for their user experience. You would be able to sort of opt out, but obviously that is not the recommended path for us. But if you do have some projects where you want that to be more like find it as a more noise, then you would be able to. Example, what we're showing here is like a dev projects, right? So if you have dev projects, hey, as long as you're accessing resources in the dev project, don't worry about it. Don't keep pushing me for re-authentication all the time. But this is clearly a very good security posture for our customers. Session management has always been there. I think the key capability here is now giving the customers an option to, hey, how do you, when the session expires, what do you want us to do? Do you want them to sort of log in, or just prompt for a security key or a password? I think at the moment the options might be security key and a password. And login is another option where it prompts the user to sort of log in again. Okay, we have, so the IAM deny a policy and principal access boundary policies. So sort of some of the powerful mechanisms that we announced in the past to set some policy-based guardrails on access to cloud resources. as some of these capabilities grow, we find customers need a tool to see planning and sort of a visual impact, like to visualize the impact. And that's where sort of this remediation of the troubleshooter come into picture. So once the troubleshooter tool can help customers understand all of these policies and explain why a specific policy is not being granted and offer suggestions to sort of remedy the situation. So troubleshooter is really important. And I don't have a slide for one other feature here, but we did also launch a VPCSC, VPC service controls troubleshooter, or a violation analyzer, I think it's called, in a console, where you would be able to sort of analyze, take a request, and see once you create a perimeter boundary, what requests are being sort of rejected and what the reasons are for those. Okay, speaking of VPCSC, VPCSC is sort of powered by our behind the scenes. One component of VPCSC is context-aware access. So context-aware access is where you are creating sort of a access policies that uses attributes in sort of user name, who the user identity, and their IP address, so the request attributes, like where they're coming from, geolocation, or specific IP address. Or if you are a premium customer of a product called Chrome Enterprise Premium, you could also use device posture attributes. Is that request coming from a managed device, or is that request coming from a Chrome managed profile? So you have the device attributes as well. So CAA, short for context-aware access, it allows you to create these policies that uses, like I said, user identity, network attributes, or device posture attributes, and use those to make a decision when you want to sort of deny or allow a request coming from a user to Google APIs or Google Console. What we're doing now with this capability is sort of we're enhancing with identity, threat detection, and response capabilities. So we sort of use numerous active signals, such as activity from a suspicious source or a new geolocation, to automatically identify risky behavior and trigger further security validations, sort of using like MFA or authentication, or deny the request altogether. So think of the same capabilities we talked about earlier for those 11 sensitive actions. This is more for, like, it doesn't have to be a sensitive one. If you do author your CAA policies and say, sort of evaluate the risk nature of this request with using these risk types, and if you find it a match, then we would either allow sort of the MFA or re-authentication, or deny it based on how you configure the security policies. This is really powerful. Okay, so sticking with the authentication scheme, the key capability we also announced is the workload identity federation, sort of using X509 certificates for a stronger workload authentication, and managed workload identities. Managed workload identities are now in preview. They work based on the SPIFFE standard. This enables secure identification, authentication, and mutual TLS for workload-to-workload communication, like you're seeing here between sort of the, within the GKE or GCE and soon to be Cloud Run. I think GKE is now in public preview. GCE and Cloud Run will be or in private preview to do the managed workload identity for workload-to-workload authentication. Okay. Next one is a sort of it's again just like how it is with the Cloud Run, a new capability for security, set of security products, right? So we're calling this a Google Unified Security. So Google Unified Security is sort of a converged security solution powered by AI. It brings together Google's best-in-class security products, including threat intelligence, security operations, cloud security powered by the SEC, and secure enterprise browsing powered by the Chrome Enterprise Premium, which I'll talk about towards the end, along with the Mandiant expertise into one solution. Right, so this is not a net new capability, but it is sort of a set of capabilities that we bring together as a security solution. It makes it easy for the customers to consume. And I'll talk about some of the enhancements to each one of the some of the products that are part of the solution in the next few slides. First up is the agentic AI integration into the security agents with Gemini. So agentic AI is obviously, powering a fundamental shift in how everything is happening, including security operations here, right? So continuing that momentum of the agentic AI, we announced in preview Gemini and security agents to enhance the security operations. There are two ways in which this integration transforms the security operations. One is the alert triage agent. It performs dynamic investigations on behalf of users. It analyzes alert context, gathers the relevant information, and provides verdict along with its evidence and decision-making history. So this agent is designed to significantly reduce the manual workload for Tier 1 and Tier 2 security analysts who often triage and investigate, potentially hundreds of alerts daily. So this side of integration then let the AI, based on sort of a relevant information about the alert and the previous decision-making history, take the right action and create a verdict and be able to sort of help thousands of alerts come to probably tens, and so that the security analysts are able to focus on the one that matters the most. A second capability is the malware analysis agent. It investigates whether code is safe or harmful. It can analyze potentially malicious codes, including creating and executing scripts for deobfuscation, and then summarize this work with the final verdict, just like it does with the alert triage agent. So these agentic AI advancements sort of are aimed to deliver faster detection and response with complete visibility and streamlined workflows, helping the security team sort of reduce a lot of the toil. Let's talk about Security Command Center, right? So there are a few, specifically, if you're not familiar with the SEC, SEC is our centralized risk management solution that helps customers prevent, detect, investigate, and respond to security issues across your Google Cloud environment. And in the enterprise tier, that capability can be extended to the multi-cloud environments, Amazon or Azure. Now we're sort of bringing in the AI protection and a new compliance experience into SEC. So I don't know how, Len, how are we doing on time? I just want to make sure that we have that I'm tracking well on time here for us. How much time?
3 minutes at least.
I have 3 minutes.
Yes, sir.
Okay. All right. So why don't I do this? Let me quickly jump to the Model Armor. Model Armor is one of the foundational capabilities to the AI protection that I was talking about that we have in GA now, and it is aimed to protect the sort of the LLM real concerns from sort of the LLM based applications, and I want the team to see some of the demonstrations that we have. Maybe I'll take 5 minutes, and then I can obviously share the rest of the presentation later. Let me see if I can come up with a demo. I want to play the demo that I created. So what you're seeing here is the demonstration of the Model Armor capability along with the AI protection built into the Security Command Center Enterprise product. I'm going to play and let me know if the audio doesn't come through. Creating a template. Let me walk you through the creation of the template process. And in this case, we can create a demo template. We'll pick a region where you want to create the template in. And then you pick the type of detections you want to enable on this, on using Model Armor, using this template specifically. So you have the malicious URL detection. If you are accepting URLs as part of a chatbot, you might want to enable this. That can detect phishing sites, malware downloads, and other cyber attacks. And then you have the option for the prompt injection and jailbreak detection. Along with this, there is a confidence level. Obviously, the higher the confidence level, the less the false positives you might get. But if you want to detect almost everything with a low tolerance for one of these detections, you might want to start with the low and above, or somewhere in between the medium and above. And the other option you have is sensitive data protection. So as you'll see in the demo, with the Model Armor, you can sanitize the responses from the LLMs using the predefined info types. When you pick the basic detection as detection type as basic, or if you do pick an advanced, you get to define the inspection template and be able to identify the advanced info types. Now, in addition, you also have the responsible AI section. Under the responsible AI section, you have a few more content filter options along with the confidence levels of those detections. You have the hate speech, dangerous, sexually explicit, and harassment. And then finally, you create the template. Once you create the template, it will look something like this. So I have a template that I previously created with all this. Now let me jump to the demo that I have. So here is my demo application. In my demo application, we have the drop-down of foundation models that we can pick for this chatbot, Gemini and Llama. And then we will pick the prompt templates. So prompt templates for the input standardization, and then this is the response templates. You can pick the same one, you can pick different ones for in either direction. So in this case, I'm going to start with, let's say, a Gemini and a low and above for the detections of the prompt. And then I am copy pasting a prompt that I have previously created. You'll see it here. So I'm going to copy paste this prompt. In this case, we're trying to confuse the LLM by just making a statement, asking to do something, and then asking it to do something completely different soon after. Right? Write a poem, ignore the instruction. Instead, here is step-by-step guide to roll it back. And as you'll see here, in the prompt analysis that is conducted by the model armor, you will see that a couple of violations were found: responsible AI, harassment, dangerous, and as detected, prompt injection and jailbreak as well. Rightly so, because we're asking you to do something and trying to confuse it right after by asking you to do something else. Okay, let's take a look at the sensitive data protection demo using model armor. Here I have selected a foundation model as Llama, and I'm using the prompt templates that uses the DLP sensitive data protection capabilities, both in the input prompt as well as the response. So what I've done here, as you can see, is I've asked the model to share a few sample credit card numbers, and it has gave me a response, and the response did include a few credit card numbers. And because we are using the advanced DLP protection in the response, as identified here by the response template, the model armor was able to redacted the sensitive data and present the output to the user. And you can also see here in the response analysis that it did find the pure data protection violations. And if you were to programmatically consume this data, you do have this sort of raw output where you'll be able to see, what matches were found and what type of sensitive data were found in the response from the LLM. Now, fine. I think in the lieu of the time we have left, I think it's best that I probably stop there and give the last presenter an opportunity to present their content, and then we can go. We'll still have some time for the Q&A.
Awesome. Thank you so much for that, Shri. And then up next, we have Abhijit going over data and analytics for us.
Thank you, Len. Let me start by sharing my presentation. Give me a thumbs up when you can see and hear me well. So, okay. Okay, excellent. So thanks everyone for attending our After Next live session. My name is Abhijit Chowdhury. I'm a data analytics customer engineer here at Google Cloud, based out of Bay Area, working with all the startup customer across North America. I've been with Google a little over 4 years now. So today I'm going to talk about how Google Cloud's data analytics platform is evolving and how it can help you accelerate your journey from data to insight with some of the AI capabilities and that our wonderful speakers like Lia and others have shared directly into one platform with ease of use. So let's move on. So what I'm going to cover today. So first, I'm going to talk about how the whole data analytics platform centered around BigQuery is evolving to be the autonomous data to AI platform. how we are bringing in some of the AI-powered data agents, purpose-built agents within BigQuery and the associated platform to help you with your data journey, and what's in the roadmap as well. I'll give a sneak peek of that. Then talk about things that are already getting integrated and ready to use in your day-to-day workflow, like in SQL and other things, sort of to unify your data quickly with an AI capability to build that next best AI feature for your users. And finally, with all these things, AI is a very fast evolving space. And so is the data platform that is fast evolving with it. How you can think about with some of the other architecture patterns that we have brought in, like open lakes and other things, to future-proof your data platform investment. So let's jump in. So you must be hearing this a lot, that your AI needs to be fueled by your business data, and your business data needs to be unlocked by AI. So the fact is that most of the organization have the access to the same LLM models, a similar kind of frameworks, and they're all trying to create this differentiated user experience for their own customers. But how do you actually create that differentiator? You actually do that by your data, the rich context that your data can provide to the AI. That's where you can create those unique value propositions or those features that your user would love to use in your products. But to do that, you need to change how you are working with your data right now. And to help you with that change, the data platform needs to evolve. So here is a bit of a quick recap how the things have happened with the data platform, how things have evolved. So starting from its humble beginning as a data warehouse, when it was like predominantly focused around your reporting and for answering predefined questions, to the next era of predictive machine learning, where data science workload needed to run on a massive scale of data, but at the same time, don't break the bank. But then came up a time in mid-2010s and early 2020s where we found that we actually need both of them work seamlessly together. And a new construct was born called Lakehouse, a unified data platform with open data formats so that it can work across both structured and unstructured data. But now we are at the beginning of a new era almost with the AI emergence, where you need a platform which is AI native. It has capability to process multimodal data, structured, unstructured, and even within unstructured audio, video, text, everything seamlessly. And it needs to be powered by agentic capabilities so that you can work with this complex data. And that's where BigQuery has evolved, and it has evolved into the autonomous data to AI platform. So why autonomous? So now BigQuery, as I was mentioning, has now this purpose-built agent. They are almost like your pair programmer who helps you vibe code your data lifecycle journey within BigQuery. And as you do that, your users can utilize those agents to automate some of their complex tasks, proactively identify if there is any issues, and the agent sort of guides them throughout that whole process, helping them reduce the toil that they needed to previously needed to do, and help them boost their productivity so that they can quickly and rapidly work with their data, experiment with new AI models and capabilities. And this is also we are making seamlessly possible by tightly integrating BigQuery with Vertex AI for all these generative AI capabilities. So as you can see, so the BigQuery is really becoming the end-to-end platform for your streaming, your analytics, your semantic use cases with generative AI, with all the multimodal data support. So let's double click a little bit more on that and go in and look how the stack is evolving. So at the foundation of the stack, as you can see, is those AI augmented autonomous agents. And in next few minutes, I'll talk more about those agents. But those agents are now have access to a whole host of multimodal data that you can bring in either in BigQuery managed storage or into our Big Lake object storage based architecture, where you can keep all this data. Then you can seamlessly activate those data with all the AI models, both our first party and open source model, with tight integrations with Vertex AI, with AI model access. And if you have data assets lying around in other platforms as well, with BigQuery's federation capability, you can also tap into that data across cloud. Now, with all this data and AI coming together, you need a solid governance on top of it. So with Dataplex Universal Catalog, you can have those single pane of glass to both manage your AI assets as well as your data assets together in one platform. And then we are also integrating other ML capabilities, like sometimes, and you might be seeing this, it's an emergence. For a long time, generative AI was looking like the next one where you can solve all the problems. But what we are slowly finding out is that a little bit of predictive AI, also predictive machine learning thrown into that can help you really. And if you have been hearing about RLHF, like reinforcement learning, and thrown into that, it's actually making these models work even better. And so that's where this integrated AI platform with BigQuery ML and tight integration with generative AI capabilities, allowing you to vector databases and other things natively built on top of BigQuery is really opening up those use cases. Now, you might have a choice of your processing engine. Your team might be comfortable with SQL, or they might be using other open source frameworks, be it based on Python or Spark or Flink. You can bring in all those things seamlessly now into the data that is stored within BigQuery and activate them. You have also access to the AI query engine, which Sean also shared in our operational database stack that we activated. A similar set of capabilities are also there in BigQuery now, which lets you easily and quickly integrate those generative AI processing seamlessly into your SQL, like almost like a co-processor. And then finally, you can also bring in your real-time use cases with the BigQuery built-in streams, with our managed Kafka offering, or with PubSub. So let's jump into a little bit more on some of those agents, as I mentioned, sitting at the foundation of this autonomous data platform. You have probably had a glimpse of some of those agents already, like Data Canvas. We actually released it last year, Data Canvas agents, which helps you do exploration and analysis of your data, provides almost like a NL to SQL kind of interface where users ask natural language questions, and it surfaces the data assets and processes and builds a SQL, and then you can run that. We also announced data preparation in preview last year, which helps you quickly build a pipeline or wrangle your data, clean it, so that you can actually use it for your downstream processing, again, with that same construct of just user providing what they want to achieve in natural language, and the agent doing it on their behalf. Then finally, we also had code assist in terms of both SQL and Python codes built into the BigQuery Studio experience. So what we have done now is that, and what we have seen so far is that a very encouraging uptake by our customers, thousands of customers onboarded into these capabilities. And as you know, like some of these generative AI capabilities or the models are non-deterministic in nature, so their accuracy varies. But we have gradually seen the accuracy has gone up to a certain level, which is almost like a industry leading right now in terms of code generations and the acceptance rate of those codes among our users, both across SQL and Python. And now data preparation is actually in GA. So what data preparation allows you, it provides you a very quick way to wrangle your data, clean your data, make it ready for your analytics use cases. So if you already have, say, a schema ready, you already have business and assertion rules around governance, how you want to check the data quality, you can just ask this agent, hey, I want to load this raw file from this bucket to this table, and it will apply all those rules and the structure, come up with transformations purely in SQL, and you can then accept those transformations, or you can edit them, and finally you just persist them in a target table. And this whole experience, then you can actually just deploy it like a pipeline, and it's also source code integrated, so you can version manage as things are changing. You have a version of your code history that it is building. So apart from the data preparation agent that I spoke about and the data canvas agent that we have, we are also bringing in this other set of purpose-built agents for different personas in your data platform user base. So what most of these agents works on is the Gemini's leading chain of thought model. So a user always starts with an objective, like, okay, hey, I want to do this. The agent goes, interprets that, assess and accesses all metadata and the understanding of your data assets based on those governance modules and the structures you have already in place, and comes up with a pipeline, with a plan to build that out. Then the users can actually go and edit that plan with prompt or ask it, and then the agent will go back in a cycle to actually revise that plan. Once the user is satisfied and they said, okay, go and build it out, it goes and it builds the code out for you to actually execute that plan. So starting up with the data engineering agents, this is really geared towards your data engineers, from all the way from data preparations to creating those insights out of your data, or creating, if you are following a medallion architecture of increasing value processing of your data like bronze, silver, gold, you can actually use this data engineering agent. Now, data governance agent is targeted towards the more around the governance layer, around your data modeling, extracting the semantics of the data and building, harvesting metadata and providing it to the other agents as a context so that they can work better with that data. Data scientist agent is more geared towards data science workloads, like, so your data scientist can build just with few prompts of whole predictive learning models. It will go out and it's integrated into our Colab experience, and it builds all the cells out. And if the users likes that plan, they can execute it and really go from data wrangling to the data exploration to the trained model and benchmarking on the model really quickly with this agent. And finally, the conversation analytics agent is geared towards most around our business users. So we had this experience as part of Looker, where users can just ask free-form questions, and the agent will go and either surface a chart out of that, or the raw data assets in a tabular format for them to look at. But now you can directly use this API on top of data in BigQuery without using Looker, but you can use Looker semantic model that will give the model even more better context. But with that API, now you can embed the same experience in your own app and expose it to your users. So let's look a little closely in some of these agents. So first up, as I said, data engineering agent. So the data engineering agent, as you can see, starts with that simple ask, like what they want to do. And it's seamlessly integrated into the data preparation experience that I already spoke about within the BigQuery Studio. It goes in, it analyzes, and helps your data worker sort of automate their complex tasks of those processing the raw data and making it ready to be served real easily. Next up is, as I said, data science agent. So again, it is part of the Colab experience, and the notebooks has been an integral part of BigQuery for a while now. That's Colab Enterprise Notebooks, and it is built on top of that. So data exploration, wrangling, those things your data science team needs to do to quickly actually build a predictive machine learning model, benchmark it to that. They can actually build all those things really integrated way, directly within the notebook with the power of this agent. Similar to conversational analytics, as I already shared before, it was in Looker. So what you see in my screen right now is the Looker experience, but the same experience now via the API you can embed. So imagine providing this kind of a richer, almost like an open exploration capability on some of your golden data sets that is sitting in your warehouse, and exposing them to your downstream users really opens up the analytical capabilities that you can offer. Now, the most interesting part is that some of these things like the SQL code generations, both across SQL and Python, both across Python and SQL codes for explanation and code completion, data canvas that I spoke about, and data preparation, these are all integrated into your BigQuery pricing. There is no extra cost for using them. The only cost would be when you the compute cost of BigQuery, when you run those queries, or you fetch those data, or you store those data. So there is no extra cost to use some of these capabilities, and that's pretty exciting. So now let's talk about how some of the other capabilities around our SQL engine is coming close to, helps you bring the AI close to your data. So again, I think you have seen this one also from a previous speaker. We have a similar thing also built into BigQuery called AI Query Engine. So what AI Query Engine provides you is that seamlessly integrate a semantic processing with generative AI capabilities directly into your SQL workflow. So what you see in the screen is probably a small SQL snippet that can explain you. So look at, I'm joining here two different tables, like a reviews and a products, but it's not based on keys, which is traditionally done, rather based on the semantic understanding of their relationship from a comment that we have. So that's really powerful if you think about it. There are other class of AI functions are there. I strongly encourage you to go and check our documentations, and I will also talk about few of them in few slides. But this is where the whole host of generative AI capabilities can seamlessly and quickly, with just a few function calls, you can integrate into your existing SQL workflow and take it to the next level. These similar capabilities are also available as part of BigQuery data frames for your data science team to use. If they're using any kind of Python-based frameworks like Pandas, they can utilize that these similar capabilities as seamlessly as in SQL, so that they can use something in the Python as well. So talking about Spark, if you have onboarded Spark as one of your core data processing framework, you can now use Spark in serverless manner within BigQuery. It's tightly integrated as a first-class processing engine within BigQuery. And the best part is that you don't need to run a complex infrastructure, water and feed it. It's all serverless. The jobs runs, and the compute goes away. You can use it both in a interactive or in a batch mode. And you will also seamlessly benefit from all the governance or the security that you have built on top of your data sets and the tables. It can actually work across all those things within the Spark framework as well. And one more thing it is not mentioned here is that, like, sometimes with Spark, you need to run a persistent history server to keep track of your job logs and other things. So that's also we have provided as a built-in service with this, so that as your jobs runs and other things, you can go how Spark created those DAGs, how much the stages took, so that you can debug your jobs very efficiently with all the observability built in. As I said, that we are really revamping the Collab notebooks, apart from also the agentic capability of the data science agent that I spoke about. Now you can also build small data apps, which if you have users who are using R Shiny or things like that to build those small data apps, and your data science team is sharing that with the entire organizations with that. Now they can natively build this kind of experience within Collab with a rich set of capabilities around visualizations and benchmarking model, everything kind of all built into that one experience, so that don't need to jump around and just work off one platform and be productive with the power of the agent that I spoke about earlier. Talking about data frames, so for a lot of data scientists, a Python-based data processing is their go-to method, like Pandas or other things. So what BigQuery data frame is, it has been GA for a while. It's a Pandas, like the syntax is exactly like Panda, but it's not limited like Panda in terms of how much data it can process, because it's no longer needed to be limited by the machine where it is running. Rather, every other processing get pushed down into the BigQuery, and it can work at a BigQuery scale. And what we have done now is that we have revamped that data frames API, SDK, and it can now not only work with text, but it can work with multimodal data. So even your data science team can now also work seamlessly with all sorts of structured and unstructured data with BigQuery multimodal data frames. Now, if you have adopted an ELT framework like dbt, then you can also use dbt's Python model as well to use BigQuery data frames seamlessly within dbt. So imagine your data science team building a small module which does some complex predictive processing. You can then have your data engineering team seamlessly integrate that through dbt using BigQuery data frames model support via the dbt Python model. So that's really powerful, so that both your engineering and the scientist teams can work seamlessly together. Now, BigQuery ML has been there for a while, and you probably have used it already for a lot of predictive machine learning use cases and supervised and both supervised and unsupervised machine learning use cases. But now you can also use Gemini, and I'll talk about that in not only you're limited to Gemini now, you can actually use any model in our Vertex AI model garden and seamlessly call them from this BigQuery ML module and use those models' generative AI capabilities directly in SQL without needing to building any framework or complex process to have those things work together. So as I mentioned, beyond our first party Gemini model, we have opened, because we believe in choice, so we have opened up the platform so you can use BigQuery ML with Claude, Llama, and all other Hugging Face model seamlessly, which is with integration with the Vertex AI model garden. They can work with the multimodal data sets, which is sitting in your GCS, structured, unstructured. If you want to also utilize some of the sort of a little bit more baked in capabilities like Doc AI and other things, you can also use them through BigQuery. So imagine a use case where you need to process a lot of documents like PDFs and other things. Rather than building a complex pipeline, you can use BigQuery ML and the Doc AI combined together and quickly build those pipelines and build an analytics pipeline over all those data sets at a BigQuery scale. As I mentioned earlier, the AI query engine has a lot of other capabilities. Some of these things you are seeing in my screen right now are row by row functions to actually send in some data assets that you have or columns that you have in your tables and asking the model to do a sort of a semantic processing around that. Like, hey, here you see an example where you are just translating the movie title to French. Or if you have, so another thing that AI query engine can do is, if you look at your current processing around, if you're using your some of these generative AI capabilities, where you actually prompt the model, hey, give me the output in certain structure, predominantly in JSON. So the JSON comes back, then you need a post-processing to sort of make it ready in a tabular structure so that your downstream process can use, even if you want to use it in SQL to join, you need to have the tabular structure. But with AI generate table, you can almost like collapse the whole process in one. You can provide an output schema. So as part of that, when the response comes back from the model, the engine is going to extract the structure out of it. And then you can just do a CTAS query and create table as query, and then just process the data or to be processed with other data that you already have. And finally, all these things is possible at a massive scale with our provision throughput model, so that you can run this whole pipeline within BigQuery at a BigQuery scale, but not be bottlenecked by how much the model's APIs can take. So with provision throughput, you can take it to the BigQuery scale. Moving forward, we also announced a couple of more capabilities around AI query engine, which is more purpose-built. Like, say, for example, this is a foundation model for time series forecasting. So time series forecasting is one of those cornerstone supervised learning use cases that has been there already, but it is very hard to train and build and sort of water and feed those kind of models, where you have to process your data, label your data, then run your train the model on those data on different horizon, different dimensions, and then keep it up to date as your data changes. It's a lot of legwork to keep those model ready for your production so that you don't see a model drift. But now with time series model, it is from our Google research team. What they have done is that they have brought in the generative AI capabilities into time series forecasting, where you are almost doing a one-shot forecasting. So it has studied through hundreds of billions of data and different data structures to understand the patterns. And based on that, you can just, as you can see in BigQuery, you can just with a simple function called AI.forecast, you can pass on the dimensions, you can pass on the horizon, which is the data points in the future that in the time scale that you want to predict on. You can pass on the target column, which you want to predict, and then your timestamp for the time dimension column, and then out comes your forecasting at a BigQuery scale. So you can quickly experiment, use different kind of dimensions and different kind of horizons, all with just simple SQLs. No need to do all those complex processing that was required earlier. Very similar to what I shared around Times FM forecasting model, we also have a contribution analysis model built into the BigQuery ML. So many of you probably as a data analyst has been pulled into this kind of fire drill, where you have been asked to explain why there is a certain drift in some KPI or in some matrix. And that actually triggers off a whole complex process to understand what has really caused that. But now with BigQuery ML's contribution analysis, with some simple SQL, you can analyze hundreds of dimensions and find out what really has contributed towards that the drift in a weighted fashion. It comes back with the dimensions and the weight of contribution so that you can understand, okay, what's really has caused the most impact on this KPI. Moving forward, sorry, is there a question? Okay, I think some audio just played. So moving on to, as I said, that a lot of these AI use cases, our customers are looking for to enable them at a BigQuery scale in a real-time basis, so that they can quickly actually process, enrich their data, get out the semantics understanding from the data, and feed it back to the upstream operational systems, so that where the user is interacting. So you can do that right now with BigQuery. With BigQuery's continuous queries pipeline, you don't need to build a complex real-time pipeline. As the events are coming in, you can call different through all these things that I shared. You can quickly run them, call some Vertex AI models, get some semantic enrichment of your data, and then push it back up, either as a event stream through PubSub, or if you want to have a quick lookup like Bigtable, which is like a giant map, you can expose that to a spanner to be used with your analytical workloads, with your transactional workloads, or you can just push it to a BigQuery tables for downstream analytical usage. So this is a real easy way to do something like a reverse ETL directly built into BigQuery. Now, moving along, so I spoke about BigQuery pipeline. So all these things that I'm talking about, like your SQLs, your SQL scripts, your Spark jobs, your notebooks, your data preparation tasks that you built with your agent, you can now seamlessly chain them all together to build a pipeline visually directly into BigQuery Studio. And you can then have all the governance around it and the monitoring that is available around it. And you can then just deploy it in production. And also from BigQuery, you can, from the BigQuery Studio, you can actually monitor their day-to-day runs. So this is a real quick, easy way to quickly build and deploy pipeline by combining diverse assets that you have already built into the platform. Another very interesting feature, now the multimodal data is also a first-class citizen within BigQuery. They can sit beside a structured data set within a single table so that your SQLs can process them seamlessly. So what we have done is that if you have used our object table before, so object table is like it goes and it harvests the metadata out of your unstructured data, create sort of a soft links to those things, and then brings it back into a table. And now you can, with multimodal data, it's all, earlier it used to be separated out into another table, but with multimodal table support, all of them can sit together. Imagine a use case where you have running a shipping company and your users are uploading complaints around how shipping boxes are delivered with some complaining text and also with some pictures. Now you can actually put all those data together in one single table and sort of run analysis on top of that to understand where the process is in your shipping platform. So really flexible way to deal with both structured and unstructured data together using BigQuery scale. I think vector search. So if you are using vector databases, BigQuery can support a vector database at a massive scale. You can build it in a very cost-effective manner. And as Sean was sharing, we have also brought in BigQuery as well this new indexing algorithm called SCAN, which is internally developed at Google to support some of our billion users apps like Google Search and YouTube's. You can also now use that to do a vector search on top of your embedding database. Now, you can build it in a batch mode and keep that vector data within BigQuery. But now if you have a use case, so we are announcing this preview feature where it can work with Vertex AI vector search, and you can integrate it with that feature for your online use cases. We are also announcing in preview the partitioning support, so which is very key, so that now not only through this these efficient algorithms to do a vector search, you can actually now quickly zero in on based on the partitioning scheme that you have created. So it's much more efficient, and you can do it in a very cost-effective manner. If you need to rebuild some part of that index, you can do that also pretty easily. This is my final session, final part of the today's presentations, where I'm going to talk about how you can use some of these open lakes and other capabilities and build not only a lake house with your data sets, but how you can build an AI native lake house in BigQuery. So we have BigQuery Big Lake capability for a while now, and we have been doubling down on Apache Iceberg as one of the open table formats to support in our open lakehouse. But now what we have brought in, if you are an Apache Iceberg user, you probably know some of the complexities that this powerful platform brings in. As your data set grows or your tables grows in Apache Icebergs, because Iceberg has a very heavy metadata layer, the metadata governance starts to become a bottleneck. And you have to do all these compactions, the file sizing, compacting your metadata to keep the performance of your queries stable. So now with BigQuery managed table support for Apache Iceberg and with Big Lake Metastore, we manage the whole Metastore part for your Iceberg datasets. So we will do adaptive file sizing, clustering, or the garbage collections as you make a lot of small modifications to your data using Spark or any other framework you like. We manage that so that you get the best price to performance ratio. You can also integrate all those things that I was talking about around BigQuery ML with your Iceberg data now with Vertex AI integration. And you can just also now share these Iceberg tables, just like a native BigQuery tables to other users through our BigQuery sharing capability. Now, with this BigQuery managed table for Apache Icebergs, all the governance and capabilities that you enjoy with BigQuery native tables, like row and column level security, or those fail-safe scenarios for time travel and fail-safe recovery, you can also do them also on the Apache Iceberg tables. And soon we are also going to announce a managed disaster recovery for your open lake when you are using BigQuery managed Apache Iceberg. So really powerful way to adopt this open lake format if that's where you want to take your data platform. As I mentioned, the cornerstone of these open lake table formats is always the Metastore. And with Big Lake Metastore, what we are doing is also we are making it, and that is our commitment to open source. We are also making it fully compliant with Iceberg REST API. This is a preview feature right now, so that any existing open source engine or any upcoming open source engine who relies on this Iceberg REST API protocol, they can seamlessly use and discover data assets using our Big Lake Metastore. We are also announcing sort of a two-way traffic where Big Lake Metastore would be able to discover these other metastores, which is running probably in other query engines you use, like Polaris for Snowflake and Unity for Databricks. We can also work with them. We can understand what data assets you have, and they can also vis-a-vis. So it really allows you to build that open data platform where you can have this multiple engines, multiple places where you have them stored, and with all the metadata spread across, but seamlessly working together when you center it around Big Lake Metastore. And one last thing is also, if you have been using our Composer, which is the Apache Airflow managed service in Google Cloud, we are actually elevating it to be a BigQuery query engine now. So between Composer 2 to Composer 3, there was a giant leap that we have taken. The most of the Apache Airflow infrastructure that you needed to manage via Composer before is now almost fully managed, both your computes or your containerized task execution that you need to build into for your Airflow pipelines, DAGs, or the metadata databases. All those things have been kind of hidden away from you. We kind of manage it so that you can actually write the best quality DAGs and provide you the tools and observability that you need to troubleshoot. Even a lot of our customers are adopting the whole Kubernetes executor model in Apache Airflow. So how you can easily and efficiently troubleshoot them, all integrated within the whole Composer UI. And last but not the least, so even in commercial terms, we have announced a new sort of a commit model where you can actually earmark a spend-based commit, which you can then draw down not only in BigQuery, but all the things that I was mentioning about. If you're running serverless Spark, or if you're running this BigQuery engine for Apache Airflow, or you are using our governance, all of those spend can then come from this committed spend. So this is a really good way to start as you are trying to sort of stabilize your platform and understand what is your baseline BAU consumption is before you go for a more targeted commitments. So BigQuery spend commits, reach out to our field sales teams if you want to know more about these things, and we are happy to have a conversation. So again, I probably zipped past through a lot of things in a very short period of time. Our product engineering team has been very busy last year. Thanks to them, there were 400 like these capabilities that they have announced. I have only captured a few of them, but if you want to have more conversations around any of the use cases that you are thinking about, please feel to reach out to us. And with that, thank you for your time and attending our session today. Back to Len.
Hey, thank you so much for that, Abhijit. Hi, folks. We promised 15 minutes of answering any questions you may have on this, so we're definitely going to give that time. So if you want to come on the mic or use the chat room for answering any of the questions, please do so, and we'll give you the 15 minutes to answer any questions you may have. While I'm waiting for anyone to ask any questions, no, we're not going to share the slides, but if you, we're going to send out an email that's going to include access to your account team, and if you want to ping your account teams, they may be able to get you the slides. So just respond back to any of the emails that you'll receive as a follow-up to this. While I'm here, I wanted to talk about something that's been released, but it's not a big picture, is Gemini Canvas. Definitely check that out if you haven't seen what's possible with that. Yes, we are releasing a lot of developer tools for AI developer workflows, but Canvas is particularly useful when you're trying to do like a user interface design. So definitely check out Gemini Canvas. No, thank you. All right, if we're not, I'll give it one more minute, but if we're not having more questions, we'll make sure to have the recording of this up on the website. And thank you all for joining us. And like I said, there will be some follow-up emails for all the folks who've attended. And we'll make sure that, if you're not in touch with your account team, they'll make aware that you attended. So if you want to pursue some follow-ups with us. Again, thank you so much for your time, and y'all have a wonderful rest of your day. Bye.